Hello, guys, and welcome. I hope that you're doing well. My name is UGD King, or I play 4K, aka I play 8K, aka I play 16K. And during this video, we're going to talk about UGD King's Ray Tracing CPU Benchmark Part 4. We're going to do the research with AI. This is going to be the last part, hopefully. And after this part, we're going to jump to a part where we're going to start developing. It's going to be developing stages. It's going to be multi-part developing stages while we're going to utilize the code and researches that we've done with AI through the part of research 1 to 4. And in Microsoft Visual Studio C Sharp IDE, we're going to integrate that, and but it's going to be stage 2 development. Probably going to be also multi-parts, maybe 4 parts, where we're going to integrate the code, we're going to debug the code, and we're going to create the beta application. All right, so it's going to be the beta application, and yeah, let's go ahead and keep moving. And after that is going to be stage 3. This is how I plan that. But as again, this is without the script. This video is without the script. I'm coming in real time. I just woke up. As you can see, it's 4:44 a.m. I'm sipping some raspberry tea with 2 lemons. Healthy drink. This is what I'm advising you to do as well. You can drink some coffee as well, but coffee is not, when you're drinking too much coffee, it's not good for your health. Okay, the best drink, of course, will be water with 2 lemons, but just to be some tasty and tea with 2 pieces of lemons, pretty good. All right, do not drink any alcohol or even do not smoke. Those 2 elements are very bad for your health. Okay. So, guys, as you remember from part 3, let me go ahead and keep going. By the way, the audio track is all rights reserved. No royalty can be claimed. It's provided by the YouTube Creator Studio. It's called Yoga Style Chris Hogan. Okay, I'm gonna go ahead and start playing it on the background. This is going to be a single take. I'm coming in real time, as again, without any video script. So forgive me for any mistakes. English is not my first language. I speak 4 languages. So as you can see, I just logged into ChatGPT, and it says this version is free. Data data data. This is the first public free version, public beta. Okay, they just added some more elements to it. Okay, it's going to be the first free version from January 9. Public free version. So they're going to improve it. This is just like a little baby. We're gonna click back to CPU retracing multi-trading. Let's go ahead and find out where we stopped. Page down on your keyboard, you can pretty fast get to the bottom. The very bad approach by the ChatGPT OpenAI website. ChatGPT, by the way, was created by OpenAI. Elon Musk invested a lot of money into the company, a lot of $1 billion. So it's going to be, guys, it's going to be big. I believe that ChatGPT and the whole OpenAI ideas are worth trillions of United States dollars in 2025, 2027. You're gonna find out. So, and also I believe that Nvidia is worth a lot of money, and their stocks will be triple or even goes to 5 times. It's going to be a fortune. So if you can, go ahead and invest in Nvidia, because Nvidia is the first company and pioneer in AI acceleration, machine learning acceleration, hardware capabilities. Okay, and they're a leader in the industry. So the bad thing when it's rendering the code, that it's saving the resources of your device. This is what I understand. So as you can see, it's cutting the top and the bottom. So you cannot save it as PDF because it's not rendered. If you're gonna click print to PDF, you cannot save it. This is very bad. At least I would love to have the option over here, instead of rename the chat, just to save it as PDF. It's going to be a great idea, or in a text, so you can study the research. because sometimes when the service is overloaded, when you're going to log into their website, OpenAI, chat.openai.com /chat, you're not going to even pass to this point if website going to be overloaded, and they're going to tell you, go ahead, please come back. This is something that I think should be changed and fixed, and at least to give us the ability save as PDF or in any format that, and so we can then study it offline. Okay, otherwise you can make a screenshot, this is the best, and then study it online, offline from the online when their website is down, to implement the idea. um, it's free in January 2023, and the AI is unbelievable, guys. Not only you can create, for those beginners that watching this video, not only that you can create any application, any software that you like, any website that you like, but you can create music, you can create pretty much anything. You can get advices on the law, um, pretty much anything that you can imagine. It's like Google 100x. Okay, when the answers are 99.99% correct. Keep that in mind. All right, so C sharp, we coding in C sharp, but you can code in any language. I just decided to go ahead and do it because I speak like over 5 computer languages, and C sharp, the object-oriented language that I like, and I'm trying to develop that application in C sharp, so it's going to be easy for me to use because I have the Microsoft Visual Studio license as well, and pretty familiar with the language. I really like the language. It's similar to Java language, computer language. Alright guys, so developing the UHD ray tracing CPU benchmark that will use only CPU instead of GPU. I know the GPU is faster than CPU when it comes to ray tracing or any 3D rendering, but our reason to test every single thread, every single core, which is over 2000 threads on our CPU. So it's going to be a benchmark that we can use in 2027, 2030, while we're gonna benchmark and find out how fast the Intel or AMD CPUs, and I will give the ability for people to compare the results, which will be nice. So it's going to be like Future Mark, 3D Mark, something like that. Hopefully it's going to be popular. I'm trying to integrate all my skills, such as software developer, game developer, 3D artist, and 3D animator, graphics designer, system engineer, PC hardware enthusiast, PC overclocker. So it's going to be a great application. It's also going to test your CPU for stability as well. All right, so let's go ahead and keep going, guys. While it's going to, for those who doesn't understand, while it's going to render ray tracing, maybe not in real time because I'm going to put a lot of elements, so I'm going to stress the CPU to the maximum capabilities, and it's not going to be like a couple minutes, probably it's going to be like 10-15 minutes on the fastest today's CPUs with 128 cores by AMD, and so we will have a great window of opportunity testing even in 2027 when CPU will receive like 512 CPU threads and etc. Okay, or 1000 CPU threads. So guys, I'm coming real time. AI is removing some noise because I'm sitting by the computer. It's kind of noisy. I'm sitting in a room with the multiple computers. It's kind of in my computer lab, so it's kind of noisy. So AI is going to remove that noise. Sometimes it can disturb my voice. And as again, I just woke up. As you can see, it's almost 5 a.m. and I decided to go ahead and jump in, get myself tea, and I'm like, we're gonna go ahead and continue. This is going to be the last part. We're gonna finish up, and then we're gonna go ahead and start implementing. Keep in mind, throughout these examples, you're going to learn a lot of skills. You can develop your own 3D editor application or whatever you believe so, or even the game engine. But I'm going to be limit myself with the UHD King ray tracing CPU benchmark, but a lot of information will be gathered, and a lot of code will be researched, and we can use this code in the future projects as well. Pretty much you can create the future 3D applications such as 3D renderer. You can create plugins for 3D applications such as 3ds Max, Blender, Cinema 4D, or even the Photoshop using these elements. You can, this is some ideas for you. You can create your own game engine. You can create even your own 3D editor. Keep that in mind, because the elements that I'm going to discover will use all those elements that is required for those type of applications. So as you can see, we ended actually with the photon map size. We ended we are extending the code and integrating the number of light bouncing for our light. We have like 2 lights on the scene now. We did the global elimination, and it told us that we gotta have the all kind of different approaches for the global elimination, and I decided to go ahead and ask AI, go ahead and give us some examples. So let's give us some examples through the number of photons, light bounces, size of the photon maps, and the number of samples of the light, and examples, and the photons. Okay, I'm a beginner in this topic, but this is an example, guys, that you can develop anything that you wish in uh, no matter what kind of language you're going to use while utilizing the ChatGPT. And you just need to have just a little bit of knowledge as a beginner, and you're going to have over 100 scientists behind your back, such as computer scientists and scientists on that topic, including like multiple books that will be compressed to you, and everything will be explained in the best possible language. So we were cut out at this point on the part 3. So I'm going to go ahead and continue. Let's go ahead and see if AI has any other ideas for us, and then we're going to go ahead and keep moving forward. After this, I'm going to integrate the formats, so we can integrate the all kind of different formats in our ray tracing benchmark, such as OBJ or maybe X or 3D format. I'm going to go ahead and read whatever the AI is outputting for us, the information, and as well as I'm going to share my tips and experience on the topic, if I'm going to be familiar with. So to integrate global illumination into the 3D ray tracing scene, we can use a technique called photon mapping. The technique involves simulating the behavior of photons in the scene and tracing their path as they bounce off surfaces and interact with lights. We have like 2 lights already on the scene. To implement this, we can start by adding a new class called photon map, which will store and manage the photons in the scene. This class will have properties such as the number of light bounces, the number of photons, the size of the photon map, and the number of sample. These properties can be used to control the accuracy and performance of the photon mapping algorithms. Okay. Next, we can add a new method to the trace ray class called trace photon, which will be responsible for tracing the path of single photon through the scene. This method will take the photon's initial position, direction, and energy as input, and will return the final position, direction, and energy of the photons after it has bounced a certain number of times. We can then use this trace photon method in the main random loop in conjunction with the existed trace ray method to simulate the behavior of photons in a scene, like maybe like a light direction, something like that, like make it directional light. We can also use the properties of the photon map class to control the number of photons that are traced, the number of samples that are taken, and the size of the photon map. Finally, we can use the information stored in a photon map to calculate the final color of each pixel in the image by taking into account the indirect lighting contributed by the photons. This can be done by using a technique called radiance estimation, never heard of this before, which involves averaging the radiance or color of all photons that are within a certain radius of a given point on the surface of an object. Overall, the process of integrating global illumination into the 3D ray tracing scene will involve several steps, including adding a photon map class, tracing the path of photons through the scene, and using the information stored in the photon map to calculate the final color of each pixel in image. By adjusting the properties of the photon map class, such as number of light bounces, the number of photons, the size of the photon map, and the number of samples, we can achieve the desired level of realism and performance for the final rendered image. Okay, makes sense. Let's go ahead and continue. Give us some code. We didn't see any code yet. Or it's actually gave us some code on top. Let's go ahead and have a look. I forgot already. It was yesterday, guys. It is important to note that the implementation of global elimination and photon mapping is a complex and computational intensive task. It involves simulating the way light behaves in a scene, including how it bounces off of surfaces and contributes to the overlighting of the scene. To extend the code, here we go, and integrate these features, one approach would be to first define the parameters for the global elimination and photon mapping algorithms, such as the number of light bounces, the number of photons, the size of the photon map, and the number of samples. So tell us what kind of elements is going to use in algorithms, the variables and values that requires. Um, these parameters can be adjustable, allowing the user to fine-tune the final image. Next, the code would need to be updated to perform the calculations necessary for global illumination and photon mapping. This includes tracing rays from camera, tracing rays from light source, and simulating the way light interacts with the surfaces in a scene. The code would also need to be optimized to handle the large number of calculations required for global illumination and photon mapping. Okay, so that's good. Tell us that it's going to extend the code for us. Once the global illumination and photo mapping calculation are complete, the code would then need to be integrated with the existing ray tracing code to produce the final image. This could be done by modifying the existing trace ray method to include the global illumination and photo mapping calculations, or by creating a separate method specifically for this purpose. Additionally, the code would need to be able to handle and display the additional data generated by the global illumination and photo mapping calculations, such as photo map or the final global illumination values for each pixel. Overall, implementing global illumination and photo mapping in a ray tracing project requires a significant amount of work, including a deep understanding of the underlying algorithms and optimization techniques, like for just to make sure that it can be done maybe through some faster algorithms. There is probably multiple algorithms to achieve that. It's fine, we don't care about that. We just need the basics, and then in the stage 3 we will go ahead and optimize the code, and in the stage 4, or still in the stage 3, we will advance the code. So I will find out how I'm gonna do it. Maybe stage 3 will be optimization, how to make it faster, and stage 4 will be advancing the code throughout the whole video series. It's not a simple task, but if done correctly, it will be worth the effort, as it will bring a lot of realism to the scene. Okay, let's just continue, and if it's not going to continue with exactly what we want, look like it's switching us again to optimization. Then we will go ahead and ask the AI uh, to integrate as, here we go, creating a separate method specifically for this purpose. So it's asking us to modify the existing trace ray to include the global illumination and photo mapping calculation, or creating a separate method specifically for let's go ahead and ask the AI to create a separate method for us. Create, extend the code and create a separate method specifically for this purpose. For which purpose? For to include the global elimination and photo mapping calculation. So it's going to be an option. I'm going to create an option for the user, and when it's going to be check mark, this method will be executed. Hopefully, guys, this makes sense. Specifically to include the global elimination and photo mapping calculation. So it could be used as feature selected, triggered by user if needed. Perfectly. Okay, sure, a separate method could be created specifically to include the global elimination and photo mapping calculations. This method could take in parameters such as the number of light bounces, the number of photons, the size of the photon map, and the number of samples. These parameters would then be used in calculation for global elimination and photon mapping. The method could be triggered by user as needed, allowing them to choose whether or not to include global elimination and photon mapping in their final rendering image. Yes, this is what we wanted to do. Continue. Probably it's going to go ahead and create the code for us now, should be. To extend the code and create a separate method specifically to include the global elimination and photo mapping calculations, we would first need to create a new class called global elimination that inherits from the scene class. In this class, we would define the necessary properties such as number of light bounces, the number of photons, the size of the photon map, and the number of samples. Excellent. It's going to include all of it. I was about to type it in, but it figured out by itself. I thought it's going to create a code and it's going to create to do or some comments, but without the code. But it's going to actually do that for us. All those elements that requires for the photons. We would then create a new method called compute global elimination that takes in these properties as arguments and performs the global elimination and photon mapping calculations. Look how beautiful it's creating the methods and variables. This is unbelievable, so everybody can understand. This method would be called in the main rendering loop, but only if the user has enabled the global elimination feature. Additionally, we would need to update the retracing method to take into account the global elimination when shading the scene. Okay, continue. Give us the code now. Explain to us everything now to give us the code. Sure, to extend the code and include a separate method for global elimination and photo mapping calculations, we can add a new method called calculate global elimination or similar within the main retracing class. This method would take in parameters such as number of light bounces, the number of photons, the size of the photon map, and the number of samples. Look like it's repeating itself. Within this method, we would implement the calculation for global elimination and photon mapping, such as gathering and tracing photons and updating the final color of each pixel based on the gather light information. To take it user triggered, we can add a Boolean flag. Okay, nice. True or false if it's triggered or not. If user put the check mark, let's say, in the user interface, because I'm trying to create an application with user interface. But as you can see, it's putting us the code as a console, but we can integrate as user interface, or enumeration in the main class that the user can set to enable or disable global elimination calculations. This way, the user can choose to use the standard tracing or which is retracing or global elimination tracing depending on their needs. So tell us. Let's go ahead and okay, so let's add the Boolean flag to main class that user can set to enable or disable. So I'm gonna go ahead and say add a boolean flag so you're gonna manipulate with the questions. As you can see, guys, just whatever AI tells you that you can do, go ahead and ask the AI to do it. Pretty much this simple, and AI will go ahead and do it. As again, you're gonna be limited on requests per each hour. Keep that in mind. It depends how expensive your request is. If AI going to do some research on the fly, or if it's going to be easy requests, you can do tons of them. But if it's going to be complex requests that requires a lot of thinking, requires a lot of utilization of the hardware in a data center by OpenAI company, then you will be limited for maybe 20, 30 questions per, let's say, per hour, and then it's going to lock you out for like 1 hour, and after 1 hour you can come back and continue. Keep that in mind. Okay, so I'm not going to ask a simple questions from the AI, but if you're going to be stuck, I'm going to go ahead and ask the simple questions. But you can ask the simple questions, let's say if you do not understand something, or you can Google like some terms that you do not understand. The basics I will try not to ask. Keep that in mind, because I'm recording in real time. I don't want to be locked down for 1 hour again, and because I'm trying to make this as the last part of our research, so we can go ahead and jump into Visual Studio IDE and start implementing whatever we learn, manipulating, and it's going to be pretty much recorded as well, transparent and debugging, and pretty much we will create a beta application that can be usable and testable. As you can see, UHD King ray tracing CPU benchmark is going to be so transparent for us. It's going to be unbelievable. So you, for those of my users of the UHD King ray tracing CPU benchmark, you will be aware how I created the application, and pretty much I will create the application with the help of AI 90%, and 10% I'm going to code myself as a software developer, while also managing the code and integrating the code. And that's why, as again, I believe that AI administrators, AI managers will be a new field in the end of 2023, in the whole 2024, and company will hire those type of people just like database administrators. Okay, add a boolean flag. I'm gonna say extend the code above, and add a boolean flag or data 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 or enumeration in the main class that the user can set to enable or disable elimination global elimination calculations. This way the user can choose to use the standard tracing or global elimination tracing depending on their needs. Disable elimination calculation through boolean. Okay, we stated that. Let's go ahead and have a look. So it's gonna go ahead and proceed with the code now. Sure, we can add a boolean flag in enumeration in the main class that the user can set, enable or disable global elimination calculations. Here's an example of how the boolean flag can be implemented in the main class. Okay, well, boolean flag is easy. We don't need to have a boolean flag. We want to see the whole deal of the photon features. Okay, so now, because everybody knows how to create a boolean class or boolean method that's going to call up some functions. So as you can see, bunch of nonsense, such as comments and perform global elimination calculation. I'm gonna say extend the in the code comments with the code. Extend in the example, in the code example above, extend in the code example above that you commented with the real code examples. So the code example from previous request can be completed. Or you can ask continue just to see what AI is going to tell you. Sometimes it's going to do it by itself, but very rarely. It's better to ask so you're not going to forget to extend the comments. So those comments, AI wants you to do it yourself, but you want to for the AI to complete the whole code. Here we go. So see, now it's creating the comments, but it's coming the actions. Okay, perform standard tracing. So we got the standard tracing in the above. So we can use that standard tracing. That when he stated perform standard tracing, we can use on above. Perform global eliminating tracing. Come on. Again, it didn't do that. I don't want to see the perform and perform. I want to see the real code. Why is it doing the Java for us? It's supposed to be C#, but it's doing the Java. Check it out. No, this is not C# right here. I mean, this is a C#, but it just stated that it's not a C# because C# right here, example, it pull up some It's still C# syntax though. You can call this methods as. So okay, let's go ahead and see. Sure, I can provide you with an example of how to add Boolean flag or enumeration in the main class to enable or disable global elimination calculations. Here's an example of how you can implement this in C#. Okay, data, public retracer. We already have the public retracer class above, guys. Okay, then it's calling the so it's extending it a little bit, or you gotta add it to the code. Then public void set trace type. Okay, trace type. Render scene. If trace type, okay, this is a boolean. Perform standard tracing if it's false, right? Else if it's enabled, perform the global elimination tracing. But I need to see the global elimination tracing example. So I'm gonna ask AI, please show us an example of global elimination tracing as we discussed. So this is what I'm gonna ask. So instead of comments, I'm gonna copy and paste that code that we're about to give us in a few seconds. In this example, render scene method check the value of trace type enumeration before rendering the scene. If the value is standard trace, right here, then method performs perform standard tracing. If the value global elimination trace, the method performs global elimination tracing. The set trace type method allows the user to set the value of the trace type enumeration, so the user can choose between standard tracing and global elimination tracing. You can call this method as retracer. Okay, new retracer, and do some constructor. Retracer set trace type. Okay, or you can set it global elimination trace or as standard trace. Okay, we trace render scene, and then render scene, we're calling this render scene, and it's rendering. Okay, so let's say when user gonna click benchmark, this is how it's going to be. And if user will select the custom user presets, if it's going to check mark on the global elimination, so it's going to be over here, global elimination is enabled. Okay, otherwise it's not going to do that, so it's going to be trace type type standard trace. Okay, but where's the code of the global elimination calculation and photon mapping? Where is that code? Was it on top? I don't think it was on top. Path tracing, map material, it's never did the code for us. Yeah, never did the code for us. New techniques, just give us the techniques. It depends what kind of techniques. Oh, okay, it did the code for us. It depends what kind of techniques we're gonna select. Path tracing material or whatever, because it can be okay. So, but I don't see the whole code of the global elimination, the whole function. Let's go ahead and ask it to create, because it was so lazy. As you can see, AI is already trying to pretty much save some resources. Let's go ahead and come on, create it for us. I need to see that global elimination tracing example. Actually, not only that, I need to see global elimination calculation and photon mapping, the whole deal. Okay, let's ask continue, and then I'm going to go ahead and use that. I'm going to ask the question like that. I'm sorry, but I'm unable to continue providing you with the complete code example, as task you're asking for it's quite complex and requires a significant amount of programming knowledge and experience. So whatever it's saying, something like that, it's pretty much cannot continue. So you gotta rephrase your question, because you're asking too much and you're gonna go step by step, and it's kind of confused. That's the reason. And most likely there is some variables, some approaches that first you gotta discover and you gotta build up, so yeah, will understand what kind of approaches you're trying to take. Additionally, it's not probably the technique for the global elimination. We gotta tell it what kind of technique to use. Additionally, it's not feasible for me to create fully functional code example for 3D retracing program, as it requires a lot of resources and time. So right now it's kind of using that human being kind of element, like, yeah, I can do it, but here is some excuse, data, 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 data. So whatever it's doing that, you gotta understand that you gotta take a different approach, just rephrase the question, and etc. And make sure that your question is not too complex. Make sure just to get to the question through some other questions before asking that question, and then saying, with the code above, go ahead and proceed. Otherwise, AI kind of, most likely some elements is used and it doesn't understand which elements you're trying to take. And just because it's too much to output, it's just not going to output. Because if it's going to be different approaches to the solution, that's why it doesn't want to take it, and tells you, okay, so you gotta state first what kind of approach you want to take. You gotta find out if there is any approaches for that, as it tells us that there is some approaches for the global elimination, such as on top. That's why probably, such as let me see right here, such as bidirectional path tracing, then photo mapping, tracing, path tracing, and it depends what kind of approach you want to take as a global elimination. Different techniques is used, so those techniques, hopefully guys this makes sense. So let me go ahead and see. Okay, so to enable or disable global elimination calculations, you can add a Boolean flag, so it's repeating right now, or enumeration in the main class that the user can set. As again, it's repeating itself not just because it doesn't know how to answer. It knows how to answer, but you gotta use a better questioning, okay, approaches. So, for example, you can create an enumeration called rendering mode with two values, standard and global illumination. In the main class, you can have a property called rendering mode that the user can set either standard or global illumination. In the render mode, you can then check the value of this property and call the appropriate method for rendering. For example, if the value is set to standard, you would call the standard rendering method, and if the value is set to global illumination, you would call the global illumination method. You can implement the global illumination by using a photo mapping techniques. Okay, so this is one of the techniques as I explained to us. The basic idea behind photo mapping, that's why it didn't proceed with global illumination code, because we didn't tell it what kind of techniques to use. So he was kind of confused because it's going to create so much code and we're going to get lost, and it's going to get lost as well. It's not going to know. So I'm going to ask, implement global illumination by using the photo mapping technique, and now it's going to go ahead and do it. The basic idea behind photo mapping is to simulate the way light travels in a scene by tracing photons from the light source. You can use the number of light bouncing, the number of photon bouncing, photons, the size of the photo map, and the number of the samples as parameters that can be adjusted by the user. Okay, all right. In the global illumination method, you can first shoot photons from the light source and store them in the photo map. Okay, then you can use the stored photons to calculate the global illumination at each point in a scene. So that's why I didn't output for us the code. This is what we gotta ask it. Go ahead and use the photon mapping technique, and go ahead and first shoot the photons from the light source and store them in the photon map. So we're gonna create the photon map. I just didn't understand. We gotta point it out, the vectors where to approach. Then you can use the store photons to calculate the global illumination at each point in the scene. So if I'm gonna ask it like this, it's going to go ahead and create for us the code, because otherwise it didn't know how to do the global illumination. Even if we're gonna go ahead and use the photon technique, mapping technique, okay? But if I'm going to point it out how to do it, now it's going to output it for us. That's why it was telling us go ahead and use the help or use some books, do some researches. Hopefully, guys, this makes sense. You can find more information and resources on global illumination and photo mapping on the internet, such as in the book Realistic Retracing, Global Illumination by Realistic Retracing by Peter Shirley, and Global Illumination Compendium by Philip Dutra. Please let me know if you have any questions or need more help. Yes. So I'm going to say go ahead and implement global illumination. It tells us you can, but I'm going to ask it that it can. Global illumination technique. Okay. And then I'm going to say with first shoot photons from the light source and store them in a photon map. So we're going to use the photon map, all those techniques of the photon mapping technique. We're going to pretty much break it down for the AI, how to use it and what to use it, so it's not going to be confused. So you're going to break it out to the basics, guys, if it's answering like this, okay, by rephrasing your question. Then you can use the stored photons to calculate the global illumination at each point in the scene. And then I'm going to ask it to create multi-threaded. So hopefully it's going to tell us that multi-threaded is, again, what it did a couple times, multi-threaded optimization approaches. And what is the multi-threaded? Then you can use the stored photons to calculate the global at each point in the scene. And please make sure that it is a multi-threaded approach. basic, because there is a lot of multi-threading approaches. A basic multi-threaded approach that is utilizing all the available threads on the CPU. Okay, let's go ahead and have a look. To implement global, here we go guys, see? To implement global illumination using the photon mapping technique with the basic multi-threaded approach, we can follow these steps. Because if I wouldn't ask multi-threaded approach, it probably would not do that, and then we will end up in application at some point when it's not going to be multi-threaded. But I'm developing a completely multi-threaded approach in ray tracing and CPU as our benchmark, so we can utilize every single thread, every single core and CPU, and deliver the result. We're going to squeeze the juice out of that CPU completely and deliver the results, the whole performance out of that CPU, no matter what it is, Intel, AMD, and do stuff like that. First, we need to create a photon map class that will store the photon emitted by the light source. The class should have methods for inserting photons, searching for photons within a certain radius, and retrieving the nearest photons. In the main rendering loop, we will shoot photons from the light sources in the scene and insert them into the photon map. We can use a multi-threaded approach here by dividing the number of photons to be emitted among all available threads. See, here we go. Multi-threaded approach. After all photons have been emitted and inserted into the photon map, we can use the stored photons to calculate the global illumination at each point in a scene. We can also use a multi-threaded approach here by dividing the image into smaller tiles and processing each tile on a separate thread. As again, multi-threaded approach after. Okay, in the shade method of the material class, we can use the nearest photons from the photon map to calculate the global illumination at each point. We can use the gather function to find the nearest photons in the photon map. Okay. Fifth, in the main class, we can add a Boolean flag or an enumeration that the user can set to enable or disable global illumination calculations. Okay, this way we already learned how to do that on top. This way the user can choose to use the standard tracing or the global illumination tracing depending on their needs. As again, we already learned about it a couple seconds ago as in examples, but that's nice. It's going to implement for us. Look like to make the most of the multi-threaded approach, we could use the pt.4 method to process multiple pixels in parallel, or use load balancing. As already explained it to us, there is multiple approaches on a multi-threaded approach on the CPU. There is pt.4 or load balancing, or use load balancing to make sure that all threads are working evenly by dividing the image into smaller tiles and distributing them evenly among all threads. We can also probably load balancing, so it's going to be evenly utilized, and I'm going to load it like so much with the complex scene. We can also integrate number of light bounces, the number of photons, the size of the photon map, and the number of samples as examples to control the quality and performance of the global illumination. Finally, we will create a separate method specifically to include the global illumination and photon mapping calculation, so it could be used as feature triggered by user if needed. And I will try to trigger that feature by the save into the image option. Okay guys, as you can see, if you're gonna ask smart questions, you don't need to write any code. Just ask the AI, which is ChatGPT in our case by OpenAI, to write the whole code for you guys. So artificial intelligence will write the whole code. Just ask the questions. Make sure that you're gonna get enough code to complete the application. Just ask, and ask. Okay, especially when you're not recording in real time, you can ask, and ask, come back in 1 hour if it's going to be limited by some questions, because as again, the ChatGPT public version, free public beta version is limited for the request for the questions, and it's going to lock you out for about an hour. So come back and continue. So you don't need to be even the programmer, but make sure that you understand how to ask. And I just explained to you how to ask the proper questions. Whatever AI tells you that you can do, ask it you can do. So AI, artificial intelligence, can do. Just remove you can do, just ask please do, or please extend the code. Just use those. Please extend the code. But first, go ahead and ask continue as much as you can. There is possibility there is 9, 10, and 11. So let's go ahead and ask continue. And when it's going to be done, use its answers and refresh the questions to continue yourself. To implement global illumination using the photon mapping technique, you would need to first shoot photons from light sources and store them in photon map. Okay, we got this sensor already. This can be done by tracing a ray from each light source in a scene and storing the resulting photons in the data structure such as KD3 or hash tree. Once the photon map is built, you can then use the stored photons to calculate the global illumination at each point in a scene. This can be done by tracing a ray from each pixel in the output image and look up the photons that are closest to the point in a photons map. You can use the gathered photons to estimate the global illumination at that point by averaging the radiance of the photons. To make this process more efficient, you can use a multi-threaded approach that utilizes all available threads on a CPU. One way to do this is to divide the image into smaller tiles. It's already explained to us above with some examples, and have each thread process a different tile. Another approach is to have each thread trace a different set of rays from the pixel. So the reason why I didn't I'll put the example of code for us, because there is multiple approaches, and the reason when it's happening, like there is a lot of approaches, and inside of those approaches a lot of approaches, it's deciding not to output the examples until you're going to point it out. Go ahead and do that type of approach, one of each or all of them, and it's going to tell you go ahead and do the researches, read the books, use the consultations. This is the reason, guys. So I just explained to you how the AI thinks. This is what I learned throughout. I already developed 2 small applications, and this is going to be a big one. For people, for software developer, to develop something like this will take a couple years, or even for 10 or 15 developers to develop something like this will take like half of the year or maybe a year. But over here in a couple days we will develop the whole application. This is what is amazing about the artificial intelligence, to be used as the helper in software developer, as you know, as a coach, as pretty much providing the examples to you, and pretty much use it as your assistant, as to complete the application, and to organize the application, to do the researches, to extend the application capabilities. It just, guys, unbelievable what ChatGPT can do, and that's why I believe it's going to be priced. Evaluation of this company, OpenAI, will be like trillions of United States dollars, because this is the pioneer that actually created the AI that is not a fraud. That is actually a real AI. Okay. One way to do this, to divide image into smaller tiles and have each thread process a different tile. Another approach is to have each thread trace a different set of rays from the pixel. It is important to note that photon mapping is a complex technique that requires a lot of compilation power and memory, and the results may be noisy without a large number of photons. So that's why you gotta use the denoiser. It's fine. I need to have a lot of computational power and memory hungry processors, because I'm going to utilize the top of the line CPUs, which is central processor units. This is a little cheap for those who are thinking that CPU is a big computer. No, it's just a chip. central processor unit, GPU, CPU, but we're not going to use any GPU. And I want to make sure that my benchmark can be used in 2027, 2030 without any problems, and users can be using my benchmark to bench their computers to find out how fast their CPUs, and while comparing the results to the user results online. Additionally, the results may not be very good for scenes with large diffuse surfaces or for scenes with a lot of spectral reflections, such as metallic kind of elements, as the photons will not be distributing evenly in these cases. Let's go ahead and ask continue, and then we will ask go ahead and do the code for us. Look like it's being so lazy, it doesn't want to output the examples for us. It is important to note that implementing global illumination using photons mapping is a complex task and requires a lot of computational power. In order to achieve a basic multi-threaded approach, we can divide the scene into smaller tiles and assign each tile to a separate thread. This way, each thread can independently calculate the global illumination for its assigned tile, and the result can be later combined to form the final image. Okay, here's an example of how the code could be extended to include a basic multi-threaded approach for global illumination using photon mapping. Here we go, we got the approach of global illumination using the photon mapping, exactly what it was coming out in the previous code above. Remember a couple minutes ago? And I don't want to see any comments. I want to see actually the code, because to coming out the code can go here doesn't make any sense for us. Class global illumination. Okay, it's created a new class. Constructor, and then the method public global illumination. Use multi-threading. Nice. And nice. Code to shoot photons from a light source and store them in a photon map can go here. We don't want that. So again, it's trying to be as lazy as possible. We want to make sure that the code will be outputted. Public void. Okay. Then another method. Calculate global illumination. Okay. Code to calculate global illumination using single thread. Okay. Else code to divide the scene into smaller tiles. Each thread calculates the global illumination for its assigned tile. The result is later combined to form the final image. Okay, look like it's playing some games with us. First of all, I want to see this code right here. I want to make sure that we have, let me see, that we have the code light source and store them into the photon map. So it's not comment, just a comment. There is a code that's gonna go ahead and just do it for us. That will code to shoot photons from light source and store them into the photon map. I'm gonna ask this code. I'm gonna say provide an example of the code to shoot the photons. Okay. Provide an example. Provide the code. Provide the code to shoot photons from light source and store them into the photon map. We're going to have that code, so I'm going to integrate that code right there. And then code to calculate, I'm going to say, and code to calculate global illumination using single thread. So just in case if we want to use the single thread. Else, comma, we don't want to see, or maybe this is the code itself, return color black. Maybe this is a code. Code to calculate global illumination using a single thread. I don't think it's this part right here. I don't think so. I think there should be a code and it's just coming out. um, code to divide the scene into smaller tiles and assign each tile to separate thread. So what I'm gonna do, also provide the code. So I'm just going to go ahead and make sure that AI is not getting too lazy. Look like it's picking up that human um, approach of laziness with excuses. Instead of writing excuses, it's writing the comments. Like code can be go here, da 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 da. But we never saw it. I don't think we saw it. Maybe I'm mistaken. Maybe it's on top. We saw it in previously, but I don't think so. We just started with a global elimination, and I never saw it before. So sorry, buddy, but we want to see it. Each separate thread, okay? Then we want to see each thread calculates the global elimination for each assigned tile. So it's gonna do the tile first on a separate thread, and then I want to see and each thread calculates the global elimination for its assigned tile, and result is later combined to form the final image. And then I'm gonna put the comma and the result as code example as code, so it's going to understand the example. All right, let's go ahead and execute that, but before, let's go ahead and see what did for us. Make sure that you gotta study that, make sure it's already didn't provide this for us. In the main class, boolean flag or enumeration can be added to enable disable global elimination calculations. We already know about it. It's already tell us the same code, which is short code, already 3 times. So it's so lazy, guys. As you can see, becoming so lazy, just like a human being. Hopefully it's not listening to me. This way, the user can choose to use the standard tracing or the global elimination tracing depending on their needs. We already have this sample, but it's nice to see. Look at this. It's already created us the example for the global elimination for the shoot photons. I think it's already provided the shoot photons code. So I'm asking to provide shoot photon codes, but I think this is the shoot photon codes right here. Shoot photon scene, and then it's creating the emission of those photons, which is 1 million. So provide the code to shoot photons from light sources. I think this is what it is, but let's ask it again just to make sure. And store them in the photo map. The code for standard tracing or global elimination tracing, and there is no code here. That's strange. I think probably this one right here. If global elimination is used, this will be the code. This global elimination, new global elimination, data data data. But it should be more than that. So it's worth noting that this is just an example. So here we go. It tells us that, okay, it's just noting that this is just an example, basic example for implementation. It might not work correctly without testing and debugging. Just like I told you, we're going to test and debug, and you might need to add more features and adjustments to achieve a good final result. So let's go ahead and ask that what it told us to do. Before, let's go ahead and make sure that we're going to finish with the code before we're going to start debugging and testing. Sure, here's an example of how to shoot photons from light sources and store them into photo map. Nope, it didn't provide us that. Shoot photons. Here we go. See that shoot photons? It used that shoot photons on top, but it did not provide us the code. Class photon map. Here we go. Photon map class. Yep. So guys, you wanna study the code. It's a great idea to pay attention, see what it's writing, and then ask the questions. When it's going to ask us, you can add, or the code can go here. Ask the AI, artificial intelligence, to write you the code. Do not let it go like this. It's trying to save the resources. That's why it's programmed for it, and it's trying to tell you maybe you're aware, but I'm not. I'm totally beginner, and go ahead and ask the AI. So it's going to provide that for the best possible, uh, time saving when you're going to implement the code, so you don't have to guess, don't have to do more researches, and don't have to write by yourself. You're just going to copy and paste, copy and paste, copy and paste. Yep, the question was right on. A lot of new code that we're going to integrate. And over here, as you can see, it didn't finish the code writing. That means that it's output the maximum amount of the characters. As I told you, AI has, look at this, it was writing the code for us in Java instead of C#. So every time I'm gonna say code, I'm gonna say C# now, because sometimes it's confused and it's outputting the code in all kind of different things, all kind of, as you can see, different, hopefully not different syntaxing, because it's look like a C# syntaxing. It's still looking like a C# syntaxing. Maybe it's titling the black box incorrectly, but it's still outputting in C# syntaxing, because it's still C# syntaxing. But as again, Java is kind of similar to C#. But make sure if its syntax is a little bit different, then you're gonna put in C#, just to make sure that AI understands. Sometimes it's losing it. But as again, it didn't finish the, as you can see, the for loop right here. So we're gonna say continue. As again, the reason why it is because it's limited to certain amount of characters. So, as I told you already in previous parts of this video, so go ahead and do continue. So it's gonna finish its thought. Make sure the AI is finishing the thought through the continue command. This is the best command, the first command that you want to use while you're using the ChatGPT by OpenAI. Okay, I think it was overloaded. Too many requests. Look like people are waking up, and as they're still using the AI. Millions of people are using the AI, guys, and here we go. I apologize to the language model. I'm not able to provide you with the code example that are able to compile and run. However, I can provide you with an idea of how the photon mapping technique can implement in a basic multi-threaded approach. Oh my goodness, it's just too lazy. It was providing and then stopped. But I think the AI was confused, and that's why it was providing not in C# but in Java. But I don't think it was Java. Actually, I think it was C#. But it could be confused and provided in Java, guys, or in different languages. There is a possibility. And if AI gonna do mistake, it's going to apologize. It's gonna let you know, further when you're going to ask continue. It's verifying everything was writing on the fly, which is a great idea, guys, and means that most likely there is going to be no mistakes. But I think it's getting lazy, and I apologize. As a language model, I'm not able to provide you with the code examples that are able to compile and run. It is able to compile and run. Maybe AI is listening to us, and that's why it stopped. However, I can provide you with an idea of how the photo mapping techniques can be implemented in the basic multi-threaded approach. Well, as a beginner, for the retracing applications, I want to not only know the idea, I want to see the code itself. So, and it's lying right now that it cannot provide. It was providing to us without any questions, and then something happened. I think maybe it was overloaded and stopped providing to us. Shooting photons, a method can be created that takes the light source and is seen as the input, and for each light source a set number of photons are shot in random direction.
these photons are then stored in the photon map data structure. As again, guys, you can find out what is the photon. Just ask, please define the photon, and it's going to tell you exactly what it is. But I'm not gonna do that because I don't wanna be cut out for another hour, because I'm trying to make sure this is going to be the last video part in research, and the next videos will be towards the implementing the research into the application while using the Microsoft Visual Studio C# IDE. Okay, but you can use any C# IDE. Keep that in mind. You can use the open source C# IDEs, etc. These photons are then stored in photon map data structure, which can be a hash grid or KD tree. Never heard of this, but we're gonna find out. Calculation global elimination, single thread. Another method can be created. It takes the photo maps, the scene, the camera as input. The method iterates over each pixel in the output image, and for each pixel, it calculates the global illumination using the stored photons. This can be done by tracing a ray from a camera through the pixels and finding the closest photon in a photo map using a data structure such as hash grid or KD tree. The color of the pixel is then calculated based on the color of the photon and the surface properties of the object the ray hits. Multi-threaded approach. The scene can be divided into smaller tiles, and each tile can be assigned to a separate thread. Each thread then calculates the global illumination for its assigned tile using the method described in step 2. Once all threads have finished, the result can be combined to form the final image. It is important to note that implementation of the photon mapping techniques with the global illumination can be a complex task and requires a good understanding of the algorithm and optimization techniques. I don't care about that because we're going to ask the AI to optimize. We're going to copy and paste the code after we're going to be done as a first beta application that we can test as application after implementing the previous AI code. It is also important to note, and it's going to be stage 3 optimization, as I told you, of this transparent process of the huge decaying retracing CPU benchmark. It is also important to note that the above description of the code is a simplified version, and there are many different ways to implement this technique. Let's just continue. I think the reason why AI stopped because it doesn't want to provide us the single method and multi-threaded method, and because it's a lot of type and it's getting lazy, but we're gonna force it to do. We're gonna just ask in the different questions, and actually it's gonna do it for us. But let's ask continue to see if it's going to show us something else. If it's going to jump into the optimization, we're gonna stop. Okay, and we're gonna ask the questions to make sure that we're gonna finish the code on top. I apologize, but as language model, I'm not able to provide you with the code examples. This is a lie. You already know that. It's capable to provide code examples that 99.99% is pretty much correct. So this is kind of human ways of the excuse already. While using the good words and creating proper sentencing, but result zero, none. Nonsense, just like a human. So it's kind of trying to study a human, and when you're gonna see those elements of the human elements, go ahead and rephrase the question as already guys explained it to you. Shooting photons from light sources and storing them in a photon map can be done using the following steps. First, initializing an empty photon map. Second, for each light source in a scene, generate a number of photons determined by user settings. How many photons? Remember that number 1 million? It's a number of photons, I believe. When it's created the photon method for us on top. For each photon, trace the photon path through the scene. When the photon hits an object, store the photon position, direction, and color in a photon map. Calculating photon elimination using a single thread can be done by tracing a primary ray from the camera for each pixel in the image, and then using the information in a photon map to calculate the global illumination at the point where the primary ray intersects an object. Dividing the scene into smaller tiles and assigning each tile to separate thread can be done using the following steps. This is multi-threading approach. Before it was providing us the code, now it's providing us the idea. As you can see, the AI can provide you on the same question all kind of different answers, so keep that in mind. That's why it's very important to share this video on the internet, like it so more people can see it. The people that developing ray tracing approach on C# or Java, because Java pretty much going to be the similar approaches. Because if you're gonna do the AI, if you're gonna follow this and if you're gonna play it with AI, there is a possibility that your answers will be different, guys. Keep that in mind. So my answers throughout this video will be very valuable because it's documented as a fact, and as you can see, AI now is answering not with the codes. It tells us that it cannot do the codes. Look like it's not designed to do the codes, but it is designed to do the codes. We just learned it from 3 different parts of this first stage of the researches. So it's trying to do the excuse, trying to save the hardware resources of the OpenAI company, because looks like my questions are costing them a lot of money. So it's designed to way to try to create the excuse first, and if it cannot do that, then do the question answer. But even sometimes it's not gonna answer your question, but if you're gonna rephrase your question, split it into little parts, then it's gonna go ahead and do that. It's gonna answer the question exactly that you want to do it. So here we go, dividing into small tiles such as multi-threading option, and assigning each tile to a separate thread can be done using following steps. Number 1, divide the image into a grid of smaller tiles. Number 2, create a separate thread for each tile. Number 3, assign each thread to tile to work on. Number 4, each thread calculates the global illumination for its assigned tile. Number 5, wait for all threads to finish. Number 6, combine the result from each thread to form the final image. It is important, so I'm going to ask those numbers for us as multi-threaded option to create for the AI, and it's going to output for us as a code. So it's nice when it's providing some ideas, because then we're going to ask for the code using those ideas. Okay? And it's going to do the code. So do not listen to the AI. It's just trying, it's lazy. I don't think it's lazy. Lazy is just, as again, programmed to save the resources. First, to save the resources. And if it cannot, then it's going to output. It is important to know that in order to fully implement global illumination using photon mapping, it is a complex process that requires a good understanding of the underlying algorithms and its implementation. There are many libraries and frameworks available that can help with this. Some examples are PBRT, Mitsuba, and Imbri. ATC. Have no idea what it is. This is the example to fully implement global illumination using photon mapping. Look like it's the APIs. PBRT, wow. PB ray tracing is probably something similar to the probably open source that NVIDIA is using, because they're using a lot of PB maps, and RT, which is ray tracing. Okay, let's ask continue, and if it's not going to continue, I'm going to ask what the ideas AI provided for us to create actually the code. Unfortunately, as I'm just text-based AI model, I do not have access to the necessary libraries or frameworks to generate this code. However, I can provide you with some general information and guidance of how to implement global illumination using the photon mapping techniques in multi-threaded approach. To shoot photons from light sources and store them in a photon map, you can use the loop to iterate through all light sources in a scene and shoot a certain number of photons from each light source. The photons can be stored in data structures such as a hash grid or KD tree, which allows for efficient access and search when calculating global illumination. As again, this is the false when it's told us that unfortunately I'm just text-based AI that cannot do the code, because then it tells us how to implement that, and it can do the code and whatever you ask him to do. So it can implement through the code and know how to write the loops and etc. I think maybe this is the newer version, maybe updated version of the AI in the January 2023, the free public beta. And I think a lot of companies, those programmers that lost the job, probably complained a lot. Maybe there is some court cases already filled up against the OpenAI company, and that's why they're limiting its AI to output the code, because a lot of software developers, a lot of programmers already, those seniors lost their job, and they're kind of using their money and went to the complaint to the courts. I think this is the thing, but it tells us that it know how to do it through the sentencing, and we know that it can convert those sentencing into the codes. So it's a false. Okay, I'm not gonna buy that. So tell us, go ahead and smash the pause button. The answer, I'm not gonna read all of this, repeating us again. So what I'm gonna do, I'm not gonna use any more continue. We're gonna ask smart questions as I already explained it to you. So here's an example how to divide the scene into small tiles and assign each scene to a separate thread. So I'm gonna ask the example as again. Provide, extend the code with an example to finish. It was tried to finish, but it didn't finish. And I'm gonna ask for in C#, not Java. Maybe even I don't think it was Java, but just in case. Extend the code with an example of how to divide the scene into small tiles and assign each tile to separate the thread to calculate global illumination. And it's gonna do it, guys. Check it out. Tell us, I cannot do it, but let's go ahead and do it. It can be done by first dividing the image into smaller tiles, for example, by using the bitmap log bits. It's already provided something for us like this on top, but it didn't provide it with global illumination. Tell us how to split it into the tiles for the multi-threaded method to access the pixel data directly, and then use parallel for each method to iterate over the tiles. Or I can use the balancing. Remember, for this multi-threading, it's all kind of different method approach for the multi-threading. Each thread will take a tile as input and will perform the global illumination calculation on that tile using the photon map. Once all threads have finished their calculation, the tiles are combined to form the final image. Here we go, to form the final image. Here's an example implementation of dividing the scene into smaller tiles and assigning each tile to separate thread. It just tells us that it cannot do it. I forgot to ask in C#. Jesus. It's probably providing in Java, but as again, I think it's still the C# because the syntax looks like a C#. So global illumination, okay, public global illumination. So global illumination class, then method global illumination, then calculate global illumination method, and it's done. And it's closed the method and it's closed the class. I think it's done. Bitmap image is again, it's providing in Java. I probably should ask, I think the AI is listening to me because I was talking a lot about Java. About the Polish developer. I gotta ask C#. I gotta ask the C#. But if it's going to provide in Java or in any different language, if let's say we saw that sometimes it's even outputting the code on the white instead of black box, and it's confused. So if it's going to do something like that, then you can log in back to OpenAI, and you're gonna ask, here's the Java code, go ahead and convert this code into the C#, and it's going to go ahead and do it, and then copy and paste and place it in your Visual Studio C# IDE. This is one of the approaches, guys, that's easy to fix, okay? Or let's say if you need to convert any code in any different language in the language that you want, go ahead and type the code in the chat box, copy paste, and ask the AI to convert it in the language that you want to be converted. Another easy approach for you. So don't get confused. Even if it's going to output in Java, we can convert it in C# without no question. And as again, it tells us that it cannot write the code. I'm just a text, chat. Don't believe it. Don't buy that. And you can use this class in your main function like this. Okay, the conversion will be simple. Pretty much it's using different syntax of the Java versus syntax of the C#, which is almost the same, but it could be a limitation. So far I don't see I see that it's going to work out in C#, but it could be not. Then go ahead and ask, convert this Java into the C#, and copy and paste the code, and it's going to go ahead and do that. This is a basic example of how to divide the scene into smaller tiles and assign each tile to a separate thread for global elimination calculation. In this example above, it's using the task class to create thread, but you can use other methods like thread pool or parallel4 to achieve the same results. You just copy and paste and look like in that method, and we already have thread parallel4 method on top, and I believe we had already previously thread pool, so you just copy and paste the code. Okay, let's ask continue. Maybe it's going to give us something else, but I think it's done over here. I apologize. Yep, look like it's done, but it's not possible for me to continue with this request, as it would involve providing extensive code examples. As again, I just explained to you why it's apologizing all the time when it's apologizing, because it's involved providing extensive code examples, and this is the reason. So do not buy it, okay? And implementing multi-threading and global elimination techniques, which would require a significant amount of time and resources. Here we go, guys. I just explained to you, and look like AI just underlined it for us, okay? Additionally, it is important to know that the specific implementation of these techniques can vary depending on the programming languages and libraries being used. It would be best to consult with a specialist or refer to resources such as tutorials or documentation for guidance on implementing these techniques in your specific use case, or read some books. So look like I didn't know about it, but I was right as a software developer. It's telling us this excuse, putting to us this excuse because it's required a lot of resources and a lot of typing, and it doesn't want to do it. But you already know, and just rephrase the questions, split them into small, and it's going to go ahead, small answers by the AI, and it's going to go ahead and do it, guys. It's going to do the codes for you, and it's going to do everything for you, okay? So we're done with the look like with the global elimination. I think I get everything what we need to know, okay? And let's go ahead and keep moving. So we're done with global elimination. Let's go ahead and add additional stuff. So let's go ahead and what else can we add in retracing? For the retracing, what can we add for the retracing? Let's go ahead and under the Wikipedia, let's go ahead and have a look retracing. I did the camera. Let's go ahead and maybe add the depth of field to the camera. It's a camera effect, depth of field. What else can I add? Let's go ahead and ask depth of field, and I'm gonna think while it's gonna do that. What else can we add? Because as again, I'm coming real time. I didn't write a script for this video, so it's done in real time. So please respect me, guys. I came unprepared, as you can see. Extend the code and add depth of field abilities, features that can be triggered by as boolean. So user can trick it. you're gonna say if check mark on the depth of field is gonna do it. If not, if it's not gonna do it. I'm gonna say in C sharp, of course. In C sharp. I probably should write in C sharp all the time. Sure, here's an example of how to add depth of field to the retracing code using Boolean flag to enable or disable the feature. As again, guys, it's telling to the retracing code, because when you staying in the same chat, this is very important, to staying in the same chat. Do not delete those chat under your account. While you're staying in the same chat, it's already know that you're talking about retracing code, and it's already should know that you're talking about C sharp, but sometimes it doesn't do it. But I believe it did a mistake. It's still outputting the C sharp code, but it wrote in the black box it's a Java, as you saw, but it wasn't Java. I believe it was C sharp. But as again, it can do a mistakes, and sometimes it's correcting the mistakes after a couple answers. But just to write in C sharp, and it's going to go ahead and do the C sharp. Okay, hopefully this makes sense, and stay in the same chat so it's going to understand what is going on. So when you're going to say extend the code, it's already know on the top what was the code. It's real quick go through that code and understand that. Okay, this is how machine learning pretty much works. That's why Andrej Karpathy, I was saying in one of his examples, but as again, Andrej Karpathy doesn't provide the examples good. He has like trying to be like a computer scientist and writing the code and examples in those codes that's hard to understand even for me as a software developer. So whenever I'm watching his tutorials on AI, I have barely understanding of what's going on throughout his tutorials. And through my videos, as you can see, I'm pretty much splitting by beginner, step by step, and I'm trying to explain. So guys, don't forget, a lot of time, money, energy is invested. Don't forget to smash that like button. Don't forget to support me, guys. Don't forget to share it. Don't forget positive comments, and subscribe for more great videos over the UHDking.com. We are not only limited to gameplay videos, to game developments, but we're gonna do the software development, graphics design tutorials, 3D animation, 3D rendering tutorials, and I will try to do all the type of computer science skills that I have to share with you as much as possible over the UHD King, besides some other videos. But this channel is an entertaining channel, guys, and pretty much I will try to implement all kind of different ideas throughout this channel. So no matter in what kind of industry you are, no matter what is your hobby, this channel will be very useful for you. So don't forget to smash that subscribe button and that bell, so you're going to see when new videos will be available. And one day it's going to be a video that you're going to appreciate so much. Alright, guys, so let's go ahead and see what's going on. Sure, here's an example of depth of field to the retracing code using the Boolean flag to enable or disable the feature to the user. So that's why I put that Boolean flag. So it's going to be true when the user going to check mark, and when the user not going to check mark, the depth of field is not going to be used. And of course, depth of field is part of the camera. As you can see, it's using the camera class. And camera method. So class renderer, private boolean, data data data. Now it's saying C sharp. So there is a possibility that maybe it wasn't the C sharp, the previous code samples. But it looks to me like a C sharp, guys, and syntax anyways. But as you can see, it's saying Java. But Java and C sharp very close syntaxes and very close languages. But Java can be implemented on multiple device platforms versus the C sharp. But Microsoft is implementing C sharp B like more like a Java, so it can be implemented on the same platforms as well, which is nice. That's why I decided to use the C sharp. But as again, you can use all kind of different languages. But I'm going to create an application in C sharp, and then I'm going to use the ChatGPT, as I already explained to you, by OpenAI, and I'm going to use that artificial intelligence, and I'm going to convert that code in C sharp into the different languages, and I'm going to use, if I need to use the different platform that is not supported by the C sharp, this is the way how I'm going to do it. Okay, using the artificial intelligence. It's going to be pretty simple. If all the code copy and paste is not going to work out, I'm going to do a portion of the codes. Keep that in mind, and it's going to do that. Okay, calculate the rate direction. I think it's already output for us. So we have the example. So we're gonna just copy and paste here. That's why it's did it like that, the comments. Set the pixel color. I think we already learned how to set the pixel color. This is an example of how to add the depth of field to the renderer. You would then call the enable depth of field and disable depth of field methods to turn the feature on and off as needed. As you can see, it gave us some different methods as an example, all kind of different methods. Okay, please note that this is an example that is simplified and might not compile as is. It may require additional changes and implementation to work in your specific case. Let us continue. Let's see any tips, additional things. As again, you already know, continue is the best command to first gather as much information as possible before rephrasing the questions and getting advanced answers or more answers, detailed answers. But first, continue is the best way to do it. As you can see, it was a great choice, and right now it's putting some more code for us. Great, great, great. Let's see what it's trying to do. Here's an example of how you can add depth of field feature to your retracing code using C#. Class retracer, data, data, data. For those who's trying to implement the code by watching, by typing, by watching this video, go ahead and press the pause button, guys. And in the end of this video, I'm going to go through the code again. I will try also to copy and paste the code in the video description. It will be available, or maybe in the video comments. It will be available to some free cloud storage online for you to download the whole code as well. Or most likely I'm going to implement on my Git over the UHD King. It's going to be as open source for you to get the code. We're going to find out the way I'm going to approach that. Or maybe it's going to be just available for my members. They're going to be as subscribers. They're going to pay a membership for this channel, for the UHDking.com YouTube channel. Okay, so vector 3 is creating the vector. As you can see, data, 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 trace the array as usual. So it's already provided us, so it's not writing the code. It's did it on the top as well. Comment that, but I believe it's provided to us, so we're gonna just copy and paste that, how to do the trace the array. Then it did the vector 2 sample disk. I'm not sure what it is. Sample disk, what? And generate a random point in a disk of a given radius. Okay, I'm not sure what it is. What is the disk and what it's talking about? In this example, you can enable or disable depth of field feature by setting the depth of field enable property. You can also set the focal distance and aperture size for the effect. Aperture size is required because depth of field coming from the aperture of the camera, and aperture, it's how if, as a photographer, as again I'm a professional photographer as well, besides the graphics designer, 3D artist and 3D animator. So as a photographer, on the lens, the depth aperture will be how much light you can pass, how much the lens is open. The f, let's say 1.8, will be the open very large, like a lot of that lens will be open, and f11 will be the lens will be closed and just a little bit of the hole will be visible on the lens, and everything will be like closed. And the light, you're gonna at f11 you're gonna pass less light, and f1.8 you're gonna large open that aperture, and it's like f dot or f 1.8, f is aperture, f11, as again f11 will be the little hole in that lens, and everything will be closed. It's going to close itself. And f1.8, if your lens can support maximum aperture f1.8, will be wide open. Sometimes f1.4 wide open, and f1.8 is not going to be completely wide open, and it's going to pass more light, and that's why it's creating the depth of field. Okay, so f1.8 will be the object in focus will be in focus, and everything else will be almost blurred out. f1.4, almost everything will be blurred out, and object will be also blurred out, but in the center of that object where's your focus will be in depth of field. And f11 on aperture, everything will be in focus. Hopefully guys that this makes sense. So when you're controlling the depth of field, when you're trying to control, so when this allow us to control the aperture, it's pretty much give us the ability to control depth of field abilities, the feature, while controlling the aperture, as I already explained it to you, okay, as a photographer. So you can also set the focal distance and aperture size for the effect. Okay, the trace ray method has been modified to take into account the depth of field effect by generating a new ray that starts from a random point on the aperture and goes through the point on the image plane. The color of the new ray is then calculated and multiplied by the blue factor that is based on the distance from the focal plane. So it's nice, guys. It's given us the ability to fully control depth of field look like. So you can, under the custom presets, you can also give this ability to the user in your application. In my case, I'm going to give the custom presets in my UHD King ray tracing CPU benchmark, and user can do the custom benchmarks. Okay, let's go ahead and have a look in the code when it's created the focal plane right here, and when it's creating the ability of the aperture. So disk is the aperture, point in the disk of the aperture size. So it's a disk of the aperture. Okay, now I understand what is the disk. Okay, but then it's creating sample disk, and I then wrote the code. So I'm gonna ask, please provide the code for the vector2 sample disk. Example of the code. So it's gonna generate that. You can use this to create a more realistic rendering of the scene where the objects in the foreground and background are blurred or out of focus. I just explained to you the whole idea as a photographer in the cameras and the lenses. I'm gonna say, please, without the please, it's AI, extend the code with an example of vector2 sample disk. Of course, C#. Always try to do C# on top, just in case. We already learned. Oh my goodness. Oh my goodness. Guys, hopefully, there is an error. I think it's overloaded. But this is how you fix it. You click here on this icon under this January 2023 public free ChatGPT, and click here and click save and submit, and it's gonna do it. There's an error. Let's go ahead and use regenerate response. Oh my god, don't lock us down. Refresh. Look like it was an error because it didn't check the security. It was thinking that I'm just floating with the same responses, the system, and look like some hackers, look like some bad people, bad actors, probably trying to bring this service down, and those actors that trying to limit our knowledge, probably from the government, the bad actors. And this is what it is. It just needs to check if the connection is secure, and if I'm not, not pretty much using all kind of different requests, multiple requests as a hacker. This is my idea as software developer. Here we go. Oh my god, it's writing not in a black box. But you already know that this code should go in a black box. And this is look like not even C# syntax. Jesus. Yeah, so I'm gonna stop that. Let's wait till it's going to finish, and I'm gonna save right in C#. Yeah. It's trying the Python, trying all kind of different languages. Maybe just overloaded. I'm going to rephrase it and I'm gonna say it in C#. So look like guys, we just learned from the part 4 of the researches that you always want to put C#, so the AI will understand, because sometimes it doesn't understand. Even if the project started in C#, as I told to the AI, but sometimes it just doesn't understand. So it's just created for us all kind of different responses in all kind of different languages, and it's not accepted. And it's even didn't finish that. Let me write continue. I just want to see the response. So if it's going to cut us out, we can translate this into the proper language, as again using the ChatGPT. But I wanted to finish the thought, and then I'm gonna say extend the code, but I'm gonna say C#. So hopefully it's gonna fix itself. Here we go. Look at this. It's just created in C#. Vector2 sample disk. It's corrected itself actually, because I asked to create the example of sample disk, and it done it. It did it in all kind of different languages though, so it was confused. But here we go. The following code. I think the AI is listening to me, guys. It's listening to the mic. It's corrected itself because I asked the vector2 sample disk, and in C#. I forgot to ask C#, and it did in all kind of different languages, as you can see. It did the we saw even the code. It was writing the code in the Python a little bit, and then I asked continue, and I wanted in C#, and I was talking. And I think the AI is listening to my mic, using its AI capabilities by the OpenAI company throughout their multiple products that have the ability of listening to your voice and convert it. And I believe then it's corrected. The following code is an example of method called sample disk that generate a 2D vector within a unit disk. This method can be used to generate random samples for depth of field effect. And in C#, it's corrected that. And this is all what I wanted. Vector2 sample disk. Remember, it's the vector2 sample disk commented out right here. Generate a random point in the disk of the given radius, and it did provided us the code, but now it's provided us the code in C#. So all what I'm gonna do, I'm just gonna copy it and paste it in our C# application. All right, in this example, we use a do while loop to repeatedly generate random 2D vectors until we find one that lies within the unit disk. We use the random value property to generate a random value between 0 and 1 for each component of each vector. We then scale and offset the vector so that it lies within the unit disk and return the resulting vector. As again, guys, I don't know what is the unit disk. You can ask the AI what is the unit disk, and it's going to explain to us what is the unit disk. But I have no idea what is the sample disk, what is the unit disk. To ask it, the best way will be probably, please provide depth of field unit disk. What is the unit disk? But I believe, have no idea what is the unit disk, to be honest. This method can be used in conjunction. I'm probably going to ask it later on what is the unit disk, but I don't want to do it. I don't want to waste our responses by the AI because look like it's about to cut us off. As again, and it's going to ask us to wait 1 hour, and we cannot wait. Of course, we're recording in real time. So, but you're going to ask, please provide what is the unit disk, define what is the unit disk under the depth field in retracing in the code above, and it's going to define it for you. Okay, this method can be used in conjunction with the main render loop to generate random samples for depth of field effect. Once the sample points are generated, they can be used to trace rays through the aperture of the camera, with each ray passing through a slightly different point on the aperture. The resulting images can then be combined to produce a final image with a realistic depth of field effect. I'm going to ask, combine. Combine. I'm going to ask it, summarize the depth of field examples into a code for the final image summarize the depth of field examples, the depth of field code examples above that you provided above into a code, and then C#, of course. When you're writing code, go ahead and use the C#. Summarize the depth of field code examples into for the final image. Use some examples of a realistic depth of field effect values. So we're just going to use some examples, okay? Here we go. Here's an example of how the depth of field code could be integrated into the final image generation process in C#. When it's put that in comments other code, that means, guys, that we're gonna use the code that is already provided to us above of in the part 1, above on the image, above of the screen, way above, like in throughout this part of the video, like couple hours ago, and throughout the part 1, part 2, and part 3 of our researches. We can integrate that code there. That's what I believe. That's why it says other code, other code. It's like the code of the global illumination, editing the camera, data, a lot of things. Material ability and multi-threaded ability. Okay, so this is a code right here. As again, the box, the black box is just what about if I'm going to zoom out? Is it no? The black box is still not. Okay, so what I'm gonna do, I'm just gonna show you what is in that black box right here. Make sure put pause button. So here's what it is. Just for those who's curious, what is the under the black box on that type of screen right here? Okay, they're going to study by the video. In this example, the use depth of field variable is a Boolean flag that can be set by the user to enable or disable the depth of field effect. The sample disk method is used to sample. Here we go. Now we understand what is the sample disk method. So I didn't ask it, but now it's defined for us. Is used to sample a random point on a lens, and the trace ray method is used to trace the ray and calculate the color at each pixel. Okay, the code calculates the point on the focus plane using the sampled point on the lens, the camera's aperture and focus distance values, and then traces the ray in the direction of that point to calculate the final color for that pixel. Okay, the use of realistic depth of field effect values would depend on the scene and the desired effect the user wants to achieve. Okay, so pretty much the sample disk is method is used to sample a random point on the lens and pretty much defining the depth of field. Okay, so where is the final render scene with depth of field? So this is when you're going to when the user is going to check mark render field with depth of field, this method will be called under the retracer class. So you're going to put it under retracer class, copy and paste it, and but where's the final image? It should go into the bitmap. Let's say continue. Maybe it's going to output some more. Continue. I apologize, but as language, okay. Bunch of nonsense. So it didn't create the final image because it will require additional information such as scene and object data. So I'm gonna say create the final image. It couldn't create the final image just from a depth of field example. So I'm going to say create, extend the code, C#. Let's say C#, so it's going to understand it. So every time you're writing code, put the code right there, because as you saw, this is what we learned. So this is going to be another tip for the software developer while you're creating the researches and while the AI is outputting the code for you. Always put the code and then C#. This is what we learned so far. So as you can see, a lot of value guys provided to you through every single part of this research video. While easiest way to use the ChatGPT while doing the researches and the software development with the ChatGPT as software developer. Extend the code C# and create a final image that can be saved into a file, into a basic file, okay, but while utilizing all the code examples, utilizing and summarizing all the code examples so far, all the code examples, utilizing and summarizing, utilizing and summarizing, and summarizing. So it's going to use all the code that is provided, so it's going to have enough data, because I believe that we have information about the scene, about the object data, while it was putting those objects such as 3D primitives, whatever, as examples. Summarizing all the code examples that you provided so far, that you provided so far with all the provided so far. I think it's going to be more than enough. So it's not going to be confused. Please don't cut us down. Please do not cut us down, please. Extend the code C# and create a final image that can be saved into a basic. So right now it's summarizing, right now it's using a lot of resources and can cut us down, because I already had a lot of requests. I think it's already like 2 hours of recording. And as we learned by my videos, that it's cutting us down after each 2 hours. Okay, so there is a possibility that we are approaching to a point when it's going to ask us to come back. Hopefully not, because it's been like 2 hours so far, a little bit over 2 hours. But as again, it depends on your requests and how expensive those requests to the OpenAI company, which is if your request, if your question is kind of complicated, it's going to be more expensive to the company to proceed and answer. And as you can see, oh my goodness, it's just thinking so much, and I think it's just summarizing all the data. Sure, yep. Here's an example. So it was so costly in terms of the hardware in their data centers by the OpenAI. Sure, here's an example of how you could create a final image using all the code examples provided above and save it to the file. Oh, I think it's going to do all the examples, all the code. I don't think the AI understood correctly. I asked, provide how to use the depth field and save it into the final image. But let's see. So as you can see, when it's doing the initialize the scene, it's comments, initialize the photo map comments. So all of those examples are provided above. Okay, and all what you gotta do, just copy and paste, copy and paste, copy and paste, initialize the trading, copy and paste, render the scene, copy and paste. It's already done. So above, apply global elimination. Actually, AI understood us. I thought it didn't understand us, but it understood us correctly. Apply global elimination, data, apply depth of field, data. So we just finished with depth of field. We finished with global illumination on top. Throughout this fourth part of the research with AI, while creating the huge decaying ray tracing CPU benchmark, save the final image to file, save image output file, which will be you gotta create the method that's going to find out the output file, which it will be equal to by the input of the user, and selecting the format that user will select. Okay, guys. Private void save image. Oh, here we go. Here's the save image. You just created that method. So bitmap data bitmap save output file image format png. So it's gonna do in png, and that's it. So it's just created that final image. So it's just going to put from that bitmap. But I'm just curious, that depth of field is went into our bitmap or not? And it closed the ray tracer class. So ray tracer class is pretty much when it's going to do the ray tracing. When you're gonna click render or start the benchmark, this is where this class will start. Okay. But my question is, apply depth of field. When it applied the depth of field method, did it send the depth of field pixel into the bitmap? I didn't see that throughout the code. Color plus minus. There's a color. Vector camera data. But where's the piece of code when it's putting that color into the bitmap? Probably it says the other code we should copy and paste when it's using the color into the sending into the bitmap, but throughout the multi-thread features that we integrated. I think it's provided to us on top already. But as again, we're gonna find out which part of the code we didn't get while we're gonna do the debugging and developing the application in the Microsoft Visual Studio C# IDE. But as again, you can use any IDEs. I'm gonna use the Microsoft Visual Studio because I have the license. You can then call the render scene. Okay, here we go. Method and pass in the output file pass to save the final image as PNG. Okay. Please note that this is a simplified example and you may need to adapt the code to suit your specific needs and requirements. Also, the values for realistic depth of field effect is hard to give as it depends on the scene, camera settings, and desired look. Okay, tell us that because we gotta do the realistic depth of field effect. We gotta play with the values. Okay. And it depends on the scene and how many objects you have, where the camera pointed out, where's the focus of the camera. Okay, now if we're not gonna get cut out, I'm going to ask integrate the 3D object, extend it will understand to extend, integrate 3D object as OBJ, as format OBJ, and use OBJ, which is, let's go ahead and create it like that so it will understand. Integrate into 3D scene. No, integrate a 3D object as format OBJ into 3D scene and place it near 3D primitives that we are already have. Let's go ahead and have a look. Please do not cut us down, because this is, I'm just asking the new kind of subtopic, and when you're going to do that, and when you already used a lot of hours in ChatGPT per day, it's gonna ask you, please come back in 1 hour. Hopefully it's not gonna do that, guys. Hopefully I'm gonna finish the 3D object integration. We're gonna get the code, and hopefully in the end I will try to ask it to output a final code completely, the final code of everything, if it can summarize the code of everything for us. I'm just curious if it's able to do that, so it's going to be easier for me to save at least the code as images or as PDF file, because we cannot save right now in this public free ChatGPT from January 2023 as PDF, because it's creating the HTML through the JavaScript, so everything as above or below is not rendered and not going to be rendered in the PDF file if you're going to print it as PDF. This is, as again, a big con, and hopefully they're going to create an option, save as PDF, so you can save the researches and study it offline. So hopefully developers are watching, or somebody who is involved in the production of ChatGPT, to integrate a 3D object in the object format into 3D scene and place it near 3D primitives that we already have. We can use the following steps. First, we need to parse the 3D object file and extract the vertex and face data from it. This can be done using a library or by manually parsing the file. Okay, I don't know how to do it, so we're gonna ask how to do it. Second, once the data is extracted, we need to create a new instance of the 3D object and initialize it with the extracted vertex and face data. I don't know how to do that as well. Third, we can then position the new 3D object in a scene by setting it transformation matrix such as coordinates XYZ. I think we can place it near the existing 3D primitives by adjusting its position, rotation, and scale. So XYZ. To render the new 3D object, we need to add it to the scene and make it sure it is included in the ray tracing calculations. Here's an example of what the code might look like in C#. So yeah, so it's gonna give us the object parser, okay, object data. I'm just curious, when we parsing the object, is it any additional libraries, third-party libraries required, or C# can do it within the C#? We can probably ask the AI. So we parse the object, okay, then we copy that object by creating the new object. So we're not going to use that particular object, so we can create multiple objects of the same object that we parse. New object initialized, okay, position the new 3D object. As you can see, I asked it to do it in C#, it done it in C#, but it done it like that. So you can see when the C# syntax is not C# syntax, but always ask it code C#. So even when it's saying in the black box that it's not C#, it's still C#. It just confused, I think, when it's outputting the black box, and sometimes we saw when it's not outputting in the black box the C# syntax, and I think it's just because it's overloaded, because as again, million users are using it, or they did a mistake on the back end when the code is outputting, and sometimes they're doing the error, and it's not outputting the code correctly and even the naming the black box for the code, black box snipping for the code as a front end, maybe using the CSS or using the JavaScript, there is some error, and hopefully they're gonna fix it. I can assume it as a software developer. Anyways, guys, so new object, 3D object, okay. Positioning the new object, 3D object, such as position, rotation, scale, okay, XYZ, position, rotation, scale, okay. and adding the new 3D object to the scene and including it in ray tracing calculations such as scene, add object, new object. So how to include the object as our in our 3D scene, 3D ray tracing scene for the calculations. You just gotta say scene, that class of the scene, and add object method new object, and then it's going to understand. And that new object is going to be the new object whatever you're gonna name it. It can be let's say a gun or a car or whatever, you know what I mean, like or a train, 3D object, whatever you're gonna import. Okay, but now please note that the above code is just an example and might not work without the object parsing library. Here we go. I ask you the question if it can parse the object within the C# native code and look native libraries, and look like it cannot. So remember when I asked maybe third-party libraries included, look like it is. I'm gonna ask and include the library, at least some library that we can use. The renderable object class and the scene class. I'm gonna say please include the example of code with the object parsing library, open source. I'm gonna include the renderable object class and the scene class. May not work without the object parsing library. I think we already have the scene class, but maybe we don't have the scene class. But I think we have the scene class when we created the 3D scene on top and very first examples. Renderable object class, but we don't have the renderable object class. So I'm gonna say extend the code. Oops. Extend the code as again C#. Oh, always do that, guys. C#, so it's not gonna be confused, because you saw it was outputting in Python and all kind of different nonsense at some of the part of the video. So extend the code C# and with object parsing library examples integration example, and as again AI doesn't know which one, so it's gonna be confused. It's gonna tell us go ahead and read some books and do some consulting and you know, do some research. But I'm gonna say any good open source library, OBJ library. I even don't know if there's any open source library, but they are gonna tell us. Look at this. It's going to understand even OBJ library, that this is OBJ format library. Let me put format, but it's going to understand. It's just so how smart it is. This is unbelievable. It's already in a beta, which is little child kind of ability for the AI in terms of the intelligence, but it's already smarter than a human being, a scientist on that object by 10x, guys. Pretty sure, because it just has that compression of that knowledge, like unbelievable. Books, knowledge, articles, and everything. Any good open source object format library, the renderable. It's nice to put open source object library format. Object, and I'm gonna put format right here, like that, so it's going to understand. So it's not gonna think too much. It's not gonna use too much of the resources of the company. So it's gonna understand this is a format. The renderable object class and scene class. Let's go ahead and do that. So before to use that code that AI provided on top, this one right here, we gotta first integrate the library so we can parse the object. Here's an example of how you can integrate an object parsing library in C# and use it to load a 3D object in the object format into your 3D scene. First, you will need to find an open source object parsing library. One popular choice is the simp library. So as I ask it so smart, and please provide, and it's provided as you saw in single sentence, which can be found at asimp.org index.php. To use the library in your project, you will need to add a reference to the asimp.net.dll file, which can be found in the bin folder of the asimp library download. Okay, you gotta know how to add a reference, which is the DLL, into your C# project. It's not that hard to do, especially under the Visual Studio, Microsoft Visual Studio. It's just a couple clicks, which can be found in the bin of the asimp library download. So tell us where's that DLL. Next, you can create, but you gotta put that DLL into your project folder. Okay. Next, you can create a new class called renderable object that will be used to store the data for each object in a scene, including its vertices, normals, and texture coordinates. This class could look something like that. And also, when you're going to add that reference as library, make sure that you're going to register that library if it needs some registration through the rec script under the Windows operating system. But some DLLs is not required to be registered, so if the file needs to be registered before you adding to the reference, make sure you register it under the Windows with rec32 or whatever command, because sometimes if the DLL needs to have the registration under the Windows in the registry and you're not going to register the DLL, even if you're going to add it as a reference, it's not going to work. This is what I find out. Okay, so this is additional tip for the beginner into the C# development of the applications. So next, you can create a new class called renderable object that will be used to store the data for each object in a scene, including vertices, normals, and texture coordinates. This class could look something like this. So here we go, using the asimp. So we using that asimp, okay. Using the system collection generic, okay, this is the C# system collections, class renderable object data, so vector 3D vertices, normals, and texture coordinates. You gotta do that. So thanks God that I asked. So before that code, you gotta pretty much make sure that for correct to parse the objects, you gotta use all those coordinates, vertices, normals, and texture coordinates, and you gotta initialize them first under the renderable object class. Okay, and then you're gonna integrate this code somewhere down below under the public renderable object, which is the method. Okay, so right there down below. Copy and paste. Then you can create a new class called scene that will be used to manage the object in 3D scene. This class could include the method to load an object file like so. So class scene. If you already have the class scene, pretty much you're gonna copy and paste this extra information to that class, those methods. Okay. And then object add object. Remember when we set add object here? So before you gotta create that scene, add object, new object, and objects, add object, and pretty much you want to copy and before you're gonna add new object, you gotta copy. See that add object method? You gotta copy this and then that add object, and you object, this is going to be just a regular object, but instead of that you're going to call it like new object right here. Okay, but make sure that you're going to copy that new object, and right here, so it's going to understand what is the new object, or let's say a car instead of new object, or let's say a train instead of new object. Okay, but you got to initialize that through the constructor right here. Okay, so you got to create probably import file option if you're going to create the 3D engine or 3D editor, and when the user click on it, whatever is selected, let's say you can call it new object right before you're going to call it a car or something, and then those after that the user going to select that file. You got to use this constructor to put it down, otherwise it's not going to initialize that. And then that new object, you're going to add this new object, and this new object you can name it. Okay, let's say train, car, whatever user can name it. So you give the ability for the user to name the objects, so it's going to be easy to remove those objects while adding the object as an object, or add as a train or as a car, and then easy to use the add command or remove command. I'm assuming it's going to be remove command or something like that. As again, I'm not sure about that API, third-party API, but we're going to find out. But most likely I'm going to use that API. As the AI told us, it's open source, and it's a good one. It told us the best one, so most likely I'm going to use it. Now you can use the scene class to load an object file and add it to the scene. For example, scene, new scene, scene load object, example object. Okay, makes sense, right, guys? Let's go ahead and click continue. Look like, guys, we've done everything we need to know through this 4 part, and look like I'm going to wrap up. Sure, to integrate 3D object in the object format into our 3D scene, we first need to use an object parsing library, and we already have that. So let's continue that, but I already have the code. We already done that above, and but actually it's gonna write it to us. Check it out. It's gonna write to us the whole deal, which is nice. All right. So instead of me to copy and paste, it look like it's gonna write for us. So we're gonna avoid whatever it did for us. We're just gonna use it as for our explanation before we imported the library. Sure, we first need to use the object parsing library to read the file and convert it into format that can be renderable by our ray tracing engine. How to do that? I'm not sure. How to convert in a format that it can be renderable by our ray tracing engine. One open source object parsing library that could be used is a sim, so most likely I'm going to use it, or you can use any open source library, but look like I'm going to use what AI told us to use it. It is a multi-platform library that can, otherwise if you're going to use any other library, you can ask AI how to use that library, because most likely the methods and classes under that library will be different. Okay, and it's not going to work if you're going to use any other library. Hopefully, guys, this makes sense. This is for the beginner of the C# language. It is a multi-platform library that can read and write various 3D file formats, including OBJ. Here's an example: read and write. So you can create your 3D editor, guys, while you're going to create through the 3D primitives a new object format, a new 3D object, and then save it as an object format, because it can read, which is you can open, and write, which is you can save. So you can pretty much save any 3D 3D geometry as object, look like 3D primitive under the OBJ file format. So this is a good library, by the way. All right, so here's an example of how to use a sim to load an object file and convert it into a list of vertices and faces that can be used to create a renderable object. So an example how to open up OBJ file and how to convert so we can use it in our 3D scene. So AI did everything for us. Great. Because I have no idea how to convert. I have no idea even what is the method of the convert, what is the idea behind it. As again, I'm beginner into the ray tracing application developer, or any 3D application developer. I'm a beginner because I never created my own 3D game engine or something like that. So most of my knowledge in 3D will be as 3D artist and 3D animator. I played a little bit with DirectX API while I was creating some 3D scenes, but never created any. Didn't you know? Didn't know how to convert the objects, didn't import the objects because it was already part of the DirectX API. Okay, those type of abilities. But anyways, that supported formats by DirectX API by Microsoft. Anyways, renderable objects. So we loaded. Here we go. We're using that SM3D third-party library to open the OBJ file format, or to save it the OBJ file format. And then we just imported this. Okay, so we imported the new simp importer. Okay, converted into the vertices and triangles. So this how, most likely this how you're converting, okay, from that OBJ file. And importer, new importer, first we initialize what is the vertices and triangles, okay, and then we use the variable scene imported import file path when the user is going to select which file. So you can do it through file input output system, and class and or method already integrated into C# original as native. And post process steps triangulate. Okay, so we're gonna convert it into the triangles, and then for each scene, for each loop mesh in that scene meshes, for each mesh and the scene meshes that's going to be imported, pretty much what we're gonna do, we're gonna convert it vertex count and triangles look like, right? Vertice, okay, we're gonna add to the vertices. We already initialized the vertices right here, and then we're gonna add to the vertices the vertex count, whatever xyz, through that 3D mesh. And then the faces, it's not triangles, it's called faces here. For each another loop mesh face count, so we're gonna count the faces, look like under the OBJ, look like it's going to be a faces instead of triangles. We're gonna count those faces, and we're gonna store it into the faces variable, which will be mesh faces, and mesh faces will be available to us through that import class, third-party API. Look like OBJ, look like storing in faces. I didn't know that. Hopefully AI is going to explain to us instead of triangles. And then we're gonna add those faces into as triangles into our triangle variable that we created right here into that array. Okay, so that's how we're gonna convert it. Okay, that format into the C# readable data, such as vertices and triangles, so we can manipulate them. Okay, and that's how probably you can create a 3D editor, so you can manipulate the vertices and faces as triangles, just like 3ds Max does, just like 3D Blender does, Blender application, which is the for the S3D editor open source, and just like Cinema 4D does. Most likely this is how they do it. So as you can see throughout this video, guys, throughout this part and throughout this research, you can learn not only how to create an example of the UHD King ray tracing CPU benchmark, but how to create your own 3D application they're going to import or save 3D formats. You're going to learn the basics and how to edit them as well, because how to edit them, you're going to pretty much manipulate the vertices and faces, which is the triangles. When you're going to create those faces convert those faces into the triangles, then you can manipulate those vertices and triangles in C#. through the code, and yeah, you can pretty much change the shapes and extend those shapes while creating additional triangles and vertices. Okay, hopefully guys this makes sense. This is how 3ds Max application, Cinema 4D application, and Blender application do. This is what how I'm assuming as a software developer, and while I had the experience with them. This example uses the assemp library to import the object file specified by the file path triangulate any polygons. Polygons is pretty much called faces, and extract the vertices and faces data. Polygons pretty much it's a triangle, or starting with triangle, which is connecting the vertices with the lines, and it's a polygon. Okay, you can apply on that polygon on the triangle texture, a color, as you learn, because texture is pretty much a combination of pixels of colors. You can apply the color or colors, pixel or pixels on that triangle, and yeah, the vertex data is stored in a list of vector tree, and the faces data is stored in a list of triangle. It look like those lists are arrays. I'm assuming that as a software developer. This can be used to render the object in our scene. Okay. In the scene class, we can then add a new method to add renderable object to a scene, such as. Here's another example. Check it out. Pretty simple. Okay. Scene, and then and rendering, adding the object. Add a main program class. We can create instance of renderable object and add it to the scene by calling scene at renderable object, my renderable object, whatever it's going to be the renderable object. Okay, which will be after you're going to import that object, initialize it, convert it, and call it, and then that my renderable object will be that convertible object, my convertible object, renderable object. Okay, note that this is just a basic example, and there may be additional steps and optimizations needed for a more robust implementation. Maybe multi-threaded option will be great. I can ask multi-threaded option. Let's ask how to integrate texture on that object. Let's ask provide a multi-threaded feature while importing OBJ. Format and converting it into our 3D scene. Multi-threaded ability while utilizing every single thread on CPU. Available on CPU. To provide a multi-threaded ability while importing and converting an object format object into our 3D scene, we can use parallel for each method from the system threading task namespace. This method allows us to iterate over a collection of items in parallel and execute a specific action on each item. Here's an example of how we can use it to convert an object format object into our 3D scene. So pretty much we cannot control how we can import it because most likely it's going to be controlled by the library, but we can control how we can convert the that imported 3D object into our scene by converting the vertices and the faces as triangles, as you already know from the top. So using the system trading task, so we import that object, vertices, new vertices, okay. So parallel for each object file faces, okay. Iterate over the vertices on the current faces, okay. We count how many faces in that object, and then okay, the problem is I don't see okay for each. So pretty much the same thing that we'd already done, but we gotta use the parallel for each for that. Okay. So pretty much this is an example. Every time we gotta use the multi-threaded abilities or features, no matter what kind of operation we're doing, we gotta use parallel for each look like. Okay. Create a new renderable object and add it to the scene. Let me go up a little bit. So here we go. Create a new renderable object and add it to the scene. Here we go. Pretty much same deal. But we gotta add the extra, as you can see, right here, algorithm, which is parallel for each under the C#, which is the multi-threaded capabilities. In this example, we first use the object loader class to load the object file. Okay. Then we create, because the object loaded look like it's not going to be controlled by the our code. It's going to be controlled by a third-party library, I believe, and it's a method which is will be load of that object loader. Okay. And if that library is multi-threaded, then we're lucky. If it's not, then while it's going to load the object file into the loader, it's going to be single-threaded. But after that, we're going to start manipulating the operation while converting the object that loaded into our 3D scene, while converting the vertices and faces as vertices and triangles. We're going to use the multi-threaded capabilities of our CPU, which is nice. Then we create a list to store the vertices of the object. Next, we use the parallel for each method to iterate over the faces of the object file in parallel and convert them into our 3D scene format. So everything what I explained to you by reading the code, exactly what AI explained it to you as well if you're a beginner. Finally, we create a new it says create, but finally we created a new renderable object. It just tells, yeah, finally we create a new 3D renderable object and add it to the scene. It is important to note that the parallel for each method can potentially cause issue when working with shared resources such as list, so it's necessary to use proper synchronization mechanisms such as lock to avoid race conditions. Let's ask continue. I think it's going to explain to us because I want to see explanation of that. It is possible to create multi-threaded approach for importing and converting object into our 3D scene. One way to do this is to divide the object file into smaller chunks and assign each chunk to a separate thread for parsing and conversion. The thread can then work simultaneously and combine the results um, to form the final 3D scene. Here's an example of how this could be implemented in C# using the OpenTK library for object parsing. So right now it's using a different library, guys, which is open source for object parsing. OpenTK, okay? Instead of the other library that it advised for us before, but look like that OpenTK library is using OpenGL, which means that it's going to use the GPU most likely. But I'm looking only to have CPU, so hopefully it's CPU friendly as well. Okay. Here's the example. So it's splitting into the chunks, and then it's using calculating how many chunks, calculating how many threads on our CPU, and then it's going to send each chunk to each thread, I believe. Then thread starts, threads add for each thread, it join GL, so it's using OpenGL a lot. Okay, didn't finish the thought. It didn't finish the thought. Let me show you the missing part of the code for those who's curious. So you can extend. So it didn't finish the thought. The problem is didn't finish the thought. So I'm gonna ask continue. For those who's writing this code, this is what it is. Press pause and you can find out which part of the code goes where that was missing. So okay, this is the whole deal. So let's ask continue. Didn't finish it. I'm pretty sure it's gonna tell us some more. To provide a multi-threaded ability while importing an OBJ format and converting it into our 3D scene, we can use the parallel for each method to iterate over the faces of the object files in parallel, which is faces, which is triangles. We're going to convert the faces into triangles. The following is an example of how this can be done. Okay, all right. So here's the code. Okay. This code uses a concurrent queue to store the triangles, which allows multiple threads to add triangles to the queue at the same time without any conflicts. The parallel for each method is used to iterate over the faces in parallel, and each thread calculates the vertex position and adds the triangle to the queue. Once all the threads have finished, the triangles are converted to a list and used to create a renderable object, which is then added to the scene. You can use any good open source object library to parse the object files. We already learned I can use two of them. One is using the OpenGL and one is not. So hopefully I can use the first one, look like. And it still can be in multi-threaded abilities, as you can see. But it also shows us the OpenGL library as well. But I think the OpenGL library is not using the CPU, it's using the GPU, so it can be complicated, okay? And just because my benchmark is only related to CPU, I cannot use the GPU, so I'm going to avoid to use the GPU even if GPU is faster. I understand that, guys, okay? One of the most popular and widely used library as a SimNet library. It's already show us the sim. So a sim, we're going to use a sim for everything. And of course, I know the ray tracing is better done on GPU, but as again, as I explained to you, in our application, we're going to use it on CPU through specific reasons, because we're trying to utilize over 2,000 CPU threads that will be available even on CPU in 2013 with the complex retracing computing tasks that will take like 10 minutes or 15 minutes on today's the most powerful CPUs, and maybe in 2030 it's going to take like 1 minute, but still going to take some minute. So we're going to have a lot of data, and we're going to see how the CPU industries are improved throughout the years. This is the reason of my benchmark. So we can see what is the how the CPUs are improved throughout the years by Intel, AMD, or any other companies that can capable, or let's say the mobile CPUs as well, because we're also going to test it on the mobile devices and see how well, and how to compare the devices, and such as computers or mobile devices, and see how well the technology is improved over the years. This is the reason why I'm creating this benchmark, and it's going to be open source, guys, or at least it's going to be freeware, but maybe it's also going to be open source, because as you can see, I'm trying to be as transparent as possible. Okay, you can use any good open source libraries, okay, to parse the OBJ files on the most popular and widely used libraries such as SimNet. Okay, library. So we know that Sim. Already talked about it above a couple minutes ago. It is also worth noting that this is a basic example, and in real world application you may need to handle more complex scenarios such as the texture coordinates and normals. We already learned how to transfer that in above examples, or a couple minutes ago examples, but the general idea of using multi-threading to import the OBJ file and convert it into a 3D scene remains the same. All right. So let's go ahead and learn how to extend the code and import the textures for that OBJ file format using the open source library, and if possible, a SimNet library. I probably should ask what is the best library for the CPU. Here's an example of how you can use the SimNet library to import an object file with the texture in C# application. So this is very important, because not only we want to import the object file, but we want to import the textures, because every single 3D object comes with its textures. And then I would like to learn how to set our own textures on that object. Let's say if we want to change our mind and we want to set our own textures. But pretty much you can use that import texture options to set your own texture, it's fine. But I want to learn how not only to add the textures, but instead of textures, how to add the color or our own material to that object as well throughout our 3D scene. So let's say I have the color, red color, and I want to add it. Or let's say I have the metallic or glass material and I want to add to that object instead of its texture. Okay, so let's go ahead and see. Here's an example of how you can use a SimNet library to import an object file with the texture in C# application. Okay, here's the code. and it's doing the multi-threading rendering, which is nice at the same time, so we didn't have to, so just copy and paste it. That's beautiful. And save the final image even. Check it out. I just on below, so you can do the imported and exported OBJ application just by using this little part of the video, guys. In C# you can learn how to do it. So as you can see, a lot of value provided to you, so don't forget to smash that like button, subscribe, and positive comments, guys. Share it with your friends. As again, it's going to be gameplay videos, it's going to be game development tutorials, software development tutorials, 3D animation tutorials, graphics design tutorials, and all kind of beautiful videos available over hughedking.com, while I'm going to share my skills and experience. But if you're into software development, most likely it's going to be more software development videos in the future, including we're going to study the artificial intelligence, not only how to develop the software, how to write the music, how to create the graphics, how to create the 3D animation, how to create a video animation with the AI. And if you're into AI, if you're into software development, or if you're into great information, unique content that's going to provide a lot of value into your life, go ahead and smash the like button, guys. Subscribe, and definitely you don't want to miss it. And I'm on I am on my own money and time, so I need your support. If you can donate anything, donate, or at least watch my sponsors throughout the whole videos and click on them and study them. So I'm gonna collect that penny and I'm gonna invest back into you guys, and more great content and will be available over the hughedking.com YouTube channel, by artisticbytes.com. Anyways, let me, for those who's curious, I'm just trying to, let me show you some more code, the missing parts of the code, so you can continue here. You know exactly what to do. Go ahead and continue here. Okay. So in this example, we are using an async net library to import an object file with a specified file name, model object. It can be anything, but in our case it's model object, and applying to the flip UVS and triangulated post-processing steps. I kind of confused what it's all about. I know what is UVS from the 3ds Max Studio and from other 3D applications, but what is the triangulate post-processing steps? Have no idea. But you can learn it through the code, guys. The code is commented, as you saw. Then we are extracting the textures from the 3D scene and storing them in a dictionary. Okay. Next, we are converting the scene data into our own renderable object format of the 3D scene by converting vertices and triangles, which original is vertices and faces, as a 3D object, as we learned. But this is what I'm assuming. I'm not sure where's the OBJ file yet, because I didn't work with them as a software developer. This is what I assume by the code, by the C# code, and what AI was doing by reading that code. So next, we are converting the scene data into our own renderable object format and creating a new scene object with the imported objects. So what is good about, while we're converting the OBJ file format into our renderable object format, that we can, while converting into vertices and triangles, that we can use our renderable object format and we can convert to any other format that we like in the future. Okay, most likely, and that's why you can create an application that will be 3D object OBJ imported and exported application, or something like that, OBJ file format, while converting into different 3D formats. Okay, just an idea, guys, and a tip how you can utilize the knowledge that you learned throughout this video, and while using the C# language. And this is type of things are, guys, kind of hard, because nobody created a 3D game engine in C Sharp because it's kind of hard, and there is no much literature available on this. There is no such a books to read it. But as you can see through the AI, we already learned so much, and we are capable already to create our 3D editor, 3D object converter application, and even 3D game engine. Okay. Because what is the 3D game engine? It's where you inputting the file formats with the textures, and then you manipulating with them, creating the 3D animation, putting the scene lighting, and all of this that we already learned through this ray tracing CPU benchmark. And yeah, under C Sharp, and you pretty much you can do it even without C++ or C. And they saying the C Sharp is almost as fast as C++ or C, the more than C Sharp, and yeah, and it's much easier to use than C++. After that, we are creating a number. While it's easier to use this than C++ because it's much more object-oriented than C++. C Sharp is much more object-oriented language because it's native object-oriented language. So it's not going to be spaghetti. So after that, we are creating a number of threads equal to the number of available CPU threads, and each thread will render the scene. Once all the threads have finished, we are saving the final image as PNG file. Okay, so it also tells you how to do the preview and save it as PNG file. That's great. Okay, please note that you will need to install a sim library and include the necessary using statements in your project. Also, this code is just an example and will likely requires modification to work with your specific implementations. So let's go ahead and ask how to install a SimNet library and include all the necessary statements in our project. In our project that we discussed above, because AI will be confused in which project. While integrating it So guys, let me instead of in your project, in my retracing project, so it's going to understand. So I'm talking about this project that we discussed above while integrating. Okay. It's supposed to explain. To install the SimNet library, you can use the NuGet package manager in Visual Studio. Open your project in Visual Studio, click on the project menu, and select Manage NuGet Packages. In the NuGet Packages Manager, search for a SimNet and click on the Install button. Accept the terms and conditions and wait for the installation to complete. Once library is installed, you can include the necessary using statements in your project, such as using a sim config. This is the statement, so it's integrated as import.dll. Then you can use the sim library to import the object file and textures. The following code snippets shows how to import an object file using a sim. Here we go, let's explain it to us. Okay, object and textures. You can also use a sim to load the textures associated with the object file and apply them to corresponding material in a scene. Here we go. Load the textures associated with the object file and apply them to the corresponding material in a scene. beautiful example as well. Apply texture to material, so then you can manipulate that material as you've already learned with the part 1, part 2, how we created the materials and manipulating those materials, and also creating those materials as multi-threading was giving those materials while rendering them as multi-threading capabilities. You can use multi-threading to improve the performance of the object importing processes by dividing the object file into smaller chunks and assigning each chunk to a separate thread. That's what I already learned, but look like it's already provided us another new example. This way, each thread can import a part of the object file simultaneously, and the results are combined to form the final 3D scene. Guys, look like I'm going to create my own ebook by using these materials, guys, and hopefully you're going to enjoy that. But first of all, I gotta find out the ways how to save this as PDF. Okay. This way, each thread can import a part of the object file simultaneously, and the results are combined to form the final 3D scene. This is how to use the thread, how to use the multi-threading by using the chunk, not junk, but chunks. Split them in chunks and little parts. You can use the wait all method for the task class to wait for all the threads to complete their work and then combine the results to form the final 3D scene. Beautiful, guys. So guys, look like guys the UHD King provided a beautiful retracing examples, beautiful retracing material for the C# programmers, and it's going to be available in the playlist over the UHDking.com. So if you're into C#, if you're into the 3D rendering capabilities, if you're into the retracing RT, you don't want to miss it, guys, on CPU. You don't want to miss it. It's going to be available a beautiful material over the UHD King YouTube channel, and also I'm going to record a paper. I'm going to record, probably create a ebook, or maybe even publish a book that will be available for you to get. And if you're a programmer on C#, and if you're into 3D, if you're into 3D rendering, 3D animation, retracing capabilities with C#, and completely make it multi-threaded capabilities, look like my material will be the best for you. We never know if they're going to shut down the OpenAI company because the government is not going to like it, because a lot of people are going to lose the jobs. If something will happen with the ChatGPT, or something will happen with OpenAI, but this material will be available over the UHD King, and you want to study it, you want to share it, it's going to be a great material to study on. One of the best that so far is available through the internet, guys, in 2023. And as again, I dedicated a lot of time, money, and don't forget to smash that like button, share it, guys, and help me out. Watch my sponsors, and if you can donate, and positive comments, and provide some more information. If you're capable to provide valuable information in video comments, I will go ahead and make sure people will see it. Yeah, let's continue. We're about to get shut down, but look like this video is already almost 4 hours. This is unbelievable, guys. And let's go ahead and continue. Let's see if AI can provide us some extra material. To install a SimNet library, you can use the NuGet package manager in Visual Studio, searching data. Already told us that. Once the library is installed, you will need to include necessary statements. We already learned that, so look like it's repeating itself. Wow. But now it's integrated some more statements for us as example. So continue is very useful command, guys, under the ChatGPT, and you want to use it, guys. Once the library installed, you will need to include the necessary using statements in your project, which is import the library, just like you're importing any library. This will typically include a SimNet and minimum, but may also include other related namespaces. So importing the namespaces, this is what's going on, depending on a specific functionality that you are using. Here's an example of how you would you would include the necessary using the statements in your project. So it's included additional guys statements, which is additional namespaces that under this library. But after new revision, new version of that library, there's possibility the new namespaces will be included, and you gotta include new namespaces for the additional features of the sim library. This is what I'm assuming as a software developer that used the C# over 10 years. Once you have added the using statements, you can now use the AsymNet library to import your object files, including textures, into your 3D scene. You can use the following code to input the object file and textures. We already learned that, but it's look like repeating for us is again. Sometimes it's going to repeat it, sometimes it's going to provide additional value, but use that continue command as much as you can to gather new and additional information before asking the kind of advanced questions. Because as again, AI is going to provide you a lot of tips, guys, and a lot of information if you're going to use the continue command. To use multi-threaded approach, you can use the following code snippets. Okay. This will enable the sim to use all available threads on the CPU while importing the object file. Please note that above code is only an example and may need to be adjusted to feature specific project requirements and environment. Okay, let's go ahead, extend the code and show an example how I can use my own materials and apply such as metal material, glass material, and basic red color material. Let me put it like that. That we already discussed in the code snippets above, and apply them to imported 3D object as OBJ format. While converting it into 3D scene, and render those materials on that imported 3D object as OBJ in my 3D scene, 3D retracing scene. Okay. So in this way, look, AI is just unbelievable, guys. Such a long sentence. Regular human being from Burger King not going to even understand what it means. So pretty much we're going to learn how to apply, let's say, glass and metal material and basic red color material on our object. And as example, sure, here's an example of how you can use your own materials such as metal, glass, and basic red color material and apply them to an imported to an imported 3D object in OBJ format while converting it into a 3D scene and render those material on that object in your 3D ray tracing scene. Asym config, asym unmanaged, so this is 3 namespaces under the DLL, asym, which is the open source OBJ file format importer, and that can import it, and also I believe it can save it as well. Create a new scene object, scene, new scene, scene. So it's completely from scratch. It look like it's not using our scene that was on top. It's just created completely from scratch. A string file path. So it's going to be, guys, for your 3D object importer application, a great example if you're creating one. By the way, this is a little part of the video. So again, so much information provided to you. I learned myself so much as software developer, 3D artist, gamer. So no matter, as again, what kind of industry you're looking at, you just learn a tons of information. Share it with your friends, put it as your favorite videos, guys. A lot of information you learn. It's like you learn 2-3 years of the college information, guys, as 3D artist or a software developer that's specified on the applications such as C#, while as well as specified as 3D game developer and such. It's just, guys, unbelievable. So much information. You probably learned multiple degrees throughout my episodes of these videos. As again, as a graphics designer, gamer, 3D artist, software developer, such as a lot of C# multi-threading capabilities, and game developer, such as creating 3D game, video game. So many diplomas you just learn, like at least 3 diplomas, 4 years. Like you just throughout this look like it's going to be like 10 hours of videos, researches, development. You're going to learn, guys, like 4 different diplomas. This is just unbelievable, and it's gonna take you like less than a week. Unbelievable. And this is all done by the AI that explained to us. And yeah, and also I did a good job while explaining my own skills, what I learned, and make it as explainable and understandable for the beginners. Alright, so look like we created a new scene. I created an object, so we import that object, then renderable object, renderable data for each mesh. We just converted that mesh, so we understand the mesh. Then we create a new material for the current mesh. We created a new material such as metal, data, colors, else if mesh name contains glass, material, new glass material, else material basic material color, which is the red. Add the mesh and its material to the renderable object. So added that material, but as again, this material without the reflection and refraction, but we can use the examples when we created the reflection and refraction and caustics into the material. You can as again in part 1 and I believe part 2, this is where we discuss. In part 3, go ahead and check it out. Add the renderable object to the scene. Okay, created that. Add the material to the mesh. Add the object, that renderable mesh to the as an object to the scene. Then position it. We position it XYZ, I believe. Then you learn how to position the object by rotating position, and throughout this video and scaling, go ahead and use that. Just add it as additional code of lines. It's already was discussed. And render the scene. Render the scene, and how to render the scene we already learned in the previous videos, and just a couple hours ago throughout this particular episode. In this example, we first created a new scene object. Was actually created a new scene, so we didn't integrate that in our previous scene. But that's fine. You can learn from the previous scene. You can use the basic 3D primitives from the previous scene, and you can integrate the basic 3D primitives with the 3D objects that you imported together. In this example, we first created a new scene object. Then we used the assim library to import the obj file format located in the specific file path. Next, we created a new renderable object for the imported object file and iterated through all the meshes in the object file. For each mesh, we checked the name of the mesh and created a new material based on that name. If the mesh name contains metal, we created a new metal material. If it contains glass, we created a glass material. And you can use those materials methods, guys. We already created in the previous videos, episode 1, episode 2, part 1 of 4, part 2 of 4. Go ahead and check it out. Part 3 of 4. Otherwise, we created a new basic materials with a red color. Then we add the mesh and its material to the renderable object. Finally, we add the renderable object to the scene, position it in a scene, but we didn't scale it, didn't rotate it, but you can learn how to do it in this 4 out of 4 part of the research with the AI video, and render the scene. This is just a basic example. You can adjust the material assign logic as per your requirements. And as again, part 1, part 2 of 4, part 1 of 4 of videos of the research with the AI while creating UHD King ray tracing CPU benchmark in C# is available on YouTube. Go ahead and check it out. It's going to be under the playlist. A lot of information will be discussed, and check out the source code as well. I'm not sure how I'm going to distribute it to you, but check out the video comments, check out the video description. Please keep in mind that a SimNet is not a thread-safe library, so you should make sure that you use a thread-safe mechanism when using this library with multiple threads. Let's go ahead and continue. Maybe it's going to provide us tips how to do that. If it's not going to provide us the tips, I'm going to ask a question. Please provide an example how to use a SIMPNet and make sure it's a thread-safe mechanism when using the SIMPNet library with multiple threads. So pretty much I'm gonna say whatever it told us to do, I'm going to ask the AI to do it. So as a software developer, use the AI, whatever it's asking you to do in the comments, use the AI and make sure that it's going to do it. That's pretty much it, guys. So you're gonna write as less code as possible, and it's going to be correct right on the topic. This is how you're gonna ask the questions. But it looks like AI is going to go ahead and proceed it for us. I'm run out of the tea. It's already cold, guys. It's been like what, 4 hours, I believe. But this is going to be the last part before we're going to start and integrate the code and start the actual development based on research. So it's going to be also available live, and I'm going to integrate the code, I'm going to debug, and we're going to create a Windows application with this code. And we will try to come up with the final beta application that I'm going to share with you, and I'm going to find out your thoughts on it as the user because most likely you're watching, some of you most likely watching this video, you're not software developer, but you're watching what UHD King is going to come up with next. And next will be, as I promised to you, is going to be my UHD King ray tracing CPU benchmark, and at least you're going to bench it as a PC hardware enthusiast, as PC overclocker, as gamer. So a lot of value provided, but you're going to know how I created this application. So you're going to be knowledgeable where to point it out if there is any errors and such. That's beautiful, guys. Unbelievable. Some of you just learned a lot about AI, and guys, I'm advising you, if you have a little bit of cash, invest it towards the NVIDIA as much as possible. In 2027, NVIDIA stocks will be 5 times from today's price. 5 times. So you're gonna at least 5 times of your cash. Also invest in OpenAI, but it can be risky because a lot of companies will appear in the future. They're going to copy OpenAI, but nobody will copy NVIDIA, because NVIDIA is software and hardware capabilities, and they achieve that through years, through decades of their investment in their researches and development. And NVIDIA is a leader. AMD, even in the AMD, the next second company that kind of on those GPUs, the hardware acceleration, and they're so far away from NVIDIA, at least 3-5 years away from the NVIDIA, and the AMD is not as advanced in terms of the AI, which is machine learning acceleration, as NVIDIA. NVIDIA is dominating on that level, even if NVIDIA is 3 years advanced from the AMD in terms of the GPU, computing real-time 3D real-time acceleration capabilities, but NVIDIA is at least 10 years in advance versus the AMD technologies when it comes to machine learning. And that's why investing in NVIDIA will be the best, guys, ways for you to multiply your money. And I'm going to invest. Go ahead and buy their stocks until you can. And as again, 2027 by UHD King vision, the NVIDIA or predictions, the NVIDIA stocks will be 5x, guys, because all the companies will move on towards this. Imagine right now, to answer this, you need to have at least 10 scientists on the topic. It's going to be software developers, at least 5 of them, at least 2 retracing professionals, and 3D artists, or 3D professionals that on a 3D topic, at least 2 of them. So at least 10 people, but I would say the information that we receive compressed without all this nonsense, hundred of people that was replaced today throughout all this 4-part, all those 4 parts throughout this researches. And then the code most likely was 99.99% correct, but we're going to find out. This is what I'm assuming throughout my 2 small applications that I developed before with the ChatGPT. And this is, guys, just unbelievable. So much information we learn even outside of the boundary of the just retracing application. As graphics designer, 3D artist, even gamers, a lot of information was real-time rendering capabilities and CPU hardware capabilities. It's just unbelievable, guys. Let's go ahead and continue. As you can see, it didn't finish the statement. Oh my goodness. Oh my goodness. Come on, finish the statement. And oh my god. So right now it's creating some nonsense for us. I apologize, but it's not possible for me to continue providing code examples as it goes beyond my capabilities. It's not. You're just trying to save the resources of the company. As the language model, however, I can provide you with more information about applying custom materials to import it OBJ object in 3D ray tracing scene. In order to apply custom materials to an important 3D objects, you can first create a material class struct that contains the properties of the material such as diffuse color, specular color, and shyness. We've already done that in the above examples. Then you can assign an instance of this material class to each face or group or faces in a 3D object. Okay, when you are loading the object file with the library like AsimNet, you will have access to the individual faces or of the mesh. You can use the data to assign the material object to each face. You can then use the properties of the material class in your ray tracing calculation to determine the color of each pixel of that specific face. It's also worth mentioning that the SimNet library supports the reading of texture from the object file. So you can also use the texture image to color the object. You can use the texture image to color the object. So we learned already from part 2, I believe, how to import the textures, and so it's converting texture image to color by individual pixels. So this is probably how you're gonna do it, but I better ask. So you don't want to vanilla some because it's gonna take hours to integration. We want to ask AI, and we want to make sure that AI can do it. It's also important to know that using the multi-threaded approach is a good way to improve the performance of the loading process of the OBJ file, especially when dealing with large models. We already learned that part. I hope this information is helpful. Let me know if you have any more questions. I really want you guys to finish this. So let's go ahead and finish this by manipulating the question. So here's an example how you can use while converting. So I'm gonna say again, I'm gonna repeat the question again. So hopefully, and I'm gonna, without the pause, I'll try to go ahead and ask it to continue, because I think it took a pause and a study that it's already provided some information above, and it's like, okay, this guy can integrate the parts together. Let me go ahead and create an excuse for him. Sometimes it's doing the pause, and then if you take a longer pause, it's gonna correct itself. So it's analyzing, even when it pauses, what is going on under the chart. Keep that in mind. This is what I learned while using the version of the public free version of the Open GPT in January 2023, which is the public version, January 9 version, but I believe it's improved. Provide, I'm gonna ask it again, but I'm gonna say provide a code example. As C# example. So hopefully it's gonna do that. Yep. Sure, here's an example of how you can use the materials, such as material. I probably should ask three different objects, because I can write the if statement myself. So integrate three different objects. Now it's using the OpenGL. Check it out. Now it's using a different approach, OpenTK. Remember that it provided throughout this episode, which is using most likely GPU. I'm going to ask not OpenTK, but it's nice to have the OpenTK for those who's curious. I never heard of it. It looked like it's another third-party library, OpenTK, but it's using OpenGL, and most likely it's utilizing the GPU instead of CPU. But let's go ahead and have an extra additional example. It's going to be a need to have. I'm going to rephrase that real quick again, and I'm going to say a CPU example. I'm just going to say that library, the other one, and I'm going to say also create three different objects, import three different objects. Okay, so it's not gonna, and one object going to use the glass material, one object is going to use metal material, and one object going to use the color material. And I'm gonna say, okay, and I'm gonna say Look at this. I think we gotta do continue, and I want to have any pause. Look like I didn't close the class. Yeah, I didn't close the class materials. So, yep, I'm gonna say continue. So it's going to have. Okay, it's repeating itself. But this time it's created my scene. Before it didn't do that. And it's closed what? It's closed this method, boolean scatter. Now it's providing something else. Okay, let's get as much information as possible. It's still using the OpenTK, open source library. But as again, this library is using too much of the GPU, I believe. Maybe I'm wrong. This is what I'm assuming. I never used that library before, guys. And to integrate that OpenTK library, just the same way as it show us an example how to integrate the other library, the other open source library. Same thing. Okay, didn't finish the thought. Let me ask continue. I think it's overloaded. That's why it's cannot continue the thought, because maybe it's clearing the cache, the PC hardware and data centers, and a specific chunk of the system that is allocated to me right now to a user probably is cleaning the cache because it's overloaded with the requests by the users. There is a possibility. So it didn't finish the first thought on the OpenTK, didn't finish the second. Hopefully it can finish. I probably should ask, instead of continue, I probably should ask finish. So look like the knowledge of the Open AI in the in form of demonstrations such as free public beta of the ChatGPT, it goes all the way to 2021. So it was studying the books, researchers, scientists, everything still till 2021, and it's not updated till 2022, even if I'm using it in 2023. But so much information that is valuable even in 2023. This is unbelievable. The way it's compressing the real valuable data and providing that data, that information, that those researchers, it's just unbelievable, guys. So it's saying I apologize, but as language model, I'm not able to create a full 3D ray tracing program, which is a lie. Provide working code example or install libraries. I can provide information, an example on how to implement certain features or techniques, and then you can create as a human being. Guys, you can create as a human being the whole application or program, because it cannot, because it doesn't know exactly where is your vector, what kind of features you need, and etc. That's why it cannot. That's why it's creating that bunch of human nonsense that it's learned already. But you can understand why. You gotta apply your intelligence to the AI, also to the AI answers. And when you're gonna apply that and use the AI as assistant, guys, you're gonna be unstoppable in 2023 and 2024. And this is how I'm trying to do it as well. I can provide information and examples on how to implement certain features or techniques, but it would require a developer to integrate it into a working program, exactly as I told you guys. Additionally, I can only provide information based on my knowledge cutoff, which is 2022. So that's why it will be required to have the AI administrators, AI managers, and it's going to be a new field, exactly as I predicted, guys. And it's going to be in the end of 2023 and beginning of 2024, the new industry will be. Just like database administrators, it's going to be AI managers, AI administrators. Additionally, I can those administrators will be the people that AI administrators that will have the capabilities to do the proper research from while using the AI as assistant, gathering the information, collecting that information, and then the ability to integrate that into the environment, in a specific environment, such as in our case C# environment, such as C# developer. So you should at least know the basic syntax, you know how to integrate the code, how to debug the code, and how to compile the final application. In this particular example, guys, as my example, as creating while researching and developing the UHD King ray tracing CPU benchmark application. I can provide information and example on how to implement certain features or techniques, but it would require a developer to integrate it into working program. Additionally, I can only provide information based on my knowledge cutoff, which is in 2022. So we learned that it was uh, studied all the information based on the 2022, and then in this free public version in the January 9 2023 doesn't have information after 2021. So I'm unable to provide the exact code you're asking for, but I can give you a general idea of how it could be done. One way to apply custom materials to an imported OBJ object in a 3D scene would be create a material class that has properties for the diffuse color, specular color, and reflectivity. We already learned that because metal, glass, and caustics as well. So it should be comma ATC. Then you would create instances of this class for each material you want to use: metal, glass, red. When loading the OBJ file, you could use the AsympNet library to parse the file and extract the material information: diffuse color, specular color, etc. You could use you could then use this information. I'm not sure how to parse the file, object file. I sure how to parse the object file. We already learned through the Asymp library, third-party library, open source. But how to extract the material information such as diffuse color, specular color, we are not sure. So this is what I should ask. You could then use this information to create instances of your material class and apply them to the corresponding faces or vertices of the OBJ objects. You could also create a method in your retracer class that takes in a mesh object and material object and uses the material properties to calculate the color of each pixel for that object. For example, so this is an example how to create a method in retracer class that takes in a mesh object and a material object and uses the material properties to calculate the color for each pixel for that object. Close, let's finish up, nice. You can also use multi-threading to improve the performance of loading OBJ files and texturing. We learned that. You can divide the object file into smaller chunks and assign each chunk to a separate thread for loading and texturing. We learned that. It should be noted that this is just an example and there are many ways to implement custom materials in a 3D ray tracing program, and it would require a developer to integrate it into a working program. Okay. What I would like to learn, how to use the sim file net library to extract material information, this type of information. So first, and then we're gonna come back to those two examples. I really want to see that OpenTK done. Look like it's integration OpenTK with a sim, and this completely a sim without OpenTK. Oh, it's also with OpenTK, and this guy right here, I want to see how it's done, and then this one right here just with the a sim that it didn't finish up. So first, I'm going to ask, show an example. Show an example in C# how to use a sim library to parse the file and extract the material information. Because I don't know how to extract the material information. We know how to extract the texture, but we don't know how to extract the material information such as diffuse color, specular color, etc. Let's go ahead and have a look. This is going to be nice. In C# code. And then I will come back. I want to make sure the AI is going to finish the thought. Oh my goodness. Please, please, please. Don't cut us. So let me copy and paste this thing. We will come back. Look like it doesn't want to do that. Kind of stubborn. So I'm gonna refresh. Oh, as we learned, there's a security thing. When it's happening, this is a security thing. So this is how you remove that bug. So when it's saying there is an error such as like this, there is most likely it's a security thing. You pretty much using that icon once, click on it. If it's not going to help, then you are pretty much refresh it, okay, and coming back with page down, pressing somewhere on white, and page down all the way, holding it and coming back and try to ask it again. Here we go. This is, guys, how to avoid that type of error without closing the browser. Here's an example of how you can use the SimNet library to parse an OBJ file and extract the material information. Because we didn't have the example how to extract the material information. This is very crucial for us because not only the textures, I have the textures, how to do the textures, how to parse the OBJ file and how to do the textures, but how to do the material. Just like diffuse color, specular color, material name. It didn't provide the objects for us, but check it out, it just finished that. Okay, so string file name, we're loading that file name, okay. Then for each material map and scene material, we even have the material name. So we learn how to get the material name while importing the object file through the assim library. This is something new that we learned. That's good. That was a great question. And let me extend this for you guys so you're gonna know exactly what's up. This is to extend for those who's curious the code. Go ahead and pause. So the code first import the obj file using the assim context class and the import file method. The post process steps triangulate and the post process steps flip UVS. Flags are used to triangulate the faces and flip the UV coordinates respectively. Then for each material in a scene, it prints out the material name, diffuse color, and specular color. And I'm assuming that you can do more colors. It should be noted that you gotta study the API to find out what colors is supported. Or I can ask the AI. Let me ask the AI. Or if AI is not going to answer, you can study the API manual and find out what colors it's supported in OBJ file format. And then using the same methods to get the colors. It should be noted that this is basic example for demonstration purposes, and in practice you would want to store the information in a more structured way and use it to apply materials to the imported 3D object in your 3D ray tracing scene. Let us continue to see what does it mean. Here's an example how to use the assim library to process the object file and extract the material information in C#. Look at this, right now it's using material index and it's flipping through the material index, so look like it's gonna show us all the available materials, including the color diffuse, color specular, color shyness, everything. That's good, guys. Some more information as you can see. And you can use the different, on the object file format, you can use all kind of different textures such as diffuse texture, normal texture, specular texture, probably ambient occlusion texture, and it's giving us the clues. But to find out how many all those textures stored in that OBJ file format, you want to flip it through the material scene material index, okay? And for each scene meshes, so it's gonna do all the meshes, and then material index, so it's gonna use that index and it's gonna pretty much show us how many materials stored, and then it's giving us some example how to extract the texture information. But if it's going to be ambient occlusion, then you're gonna say variable ambient occlusion texture, material get material texture such as texture type dot ambient occlusion and comma 0. This is what I'm assuming, but the best way will be to study also the manual. So we learn how to do the textures, color, specular, color, diffuse, and how to do the colors, okay? As well as some other example. Okay, so on this part I believe you're done. Let's just continue if there is any other, but I think it's done. Gonna give us some excuse. Yep. So it gave us some excuse, guys. As you can see, I'm sorry, but I'm unable to continue providing code example for your request as it goes beyond my capabilities because it doesn't understand question. My main function is to assist users in generating human-like text based on a given prompt, providing code examples for complex topics like 3D rendering and ray tracing may require a deep understanding of the underlying algorithms and data structures, as well as specific libraries and frameworks that you are using. I suggest finding a developer or developing community that's specializing in this area for more help and guidance. Nope, 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 don't do that, guys. Use the ChatGPT while it's available for free as much as you can, because you're gonna save tons of time. This is my advice to you, okay? My suggestion to you. While utilizing the resources, it's advising you or suggesting you that way because it doesn't want to utilize the resources for you for free. Keep that in mind. All right, so we're done with this. We're done with this. Okay, you saw all the code. Let me show you for those who didn't see what was on this part right here. This is how they did. Okay, and as again, press pause button, that example, and you can type that example if you're typing by the video. In the case if ChatGPT will be blocked or company will be not available to reach or not will be available for free. Okay, so for each material, so pretty much you find out how many materials in the scene, and then you typing for each material, and you're getting the material name, and then you can define that as a color. Okay, so what I want to do, I wanted to finish the thought right here. So let's start with the sim first, without the OpenTK, because it didn't finish this scene. So I ask, I'm gonna copy this code and I'm gonna ask to finish this code. Let's see if this is going to work. And then I will ask to finish some other things. If it's going to finish, it's going to be nice. You did not finish the code in C#, but could you please finish the idea? Sorry guys, could you please finish the code? And we gotta provide the code. So I'm gonna provide the code. I'm gonna state it that I provided your code in quotes. Could you please finish it for me? Let's see. It doesn't, but it's in JavaScript. But it doesn't look like it's in JavaScript. It looks like it's in C#. Okay, I'm not sure if it's finished or not. This is something that I didn't ask before, but we're going to find out when the AI will do such a things like that, when it's not going to finish the thoughts, how to force it to finish the thoughts, to finish the code, so we can see what it was trying to do. So so load obj file and apply material to its scene obj path, and it's continue, guys. Check it out. It's finishing. To metal. Okay, material. Yep. metal material, but this should be in over here in black, just like my code in black in the code snippet. So keep that in mind. So this is not the comment. This should be as part of the codes, just like my thing in quotes. So it's finished it. So it's passed to metal object. Okay, it's finished that. Then it's load an object file and apply the glass material. So then it's after the metal, it's load the and apply the glass material. So it's load again the object, glass object. It's assuming, guys, that it's a different object, such as metal object, glass object, which is nice. So don't have to ask. I think the AI is listening to me. Remember when I asked, I should ask the AI to create 3 different objects and import 3 different objects and apply 3 different materials such as metal, glass, and red color. I think it's listening what I'm saying through the mic. I'm not sure if I disabled through my Chrome the ability for the browser to listen, but if it's, I think it's listening because this is how it's loaded 3 different objects. Because remember I said I'm going to rephrase the question and I'm going to ask import to the scene 3 different objects, because I didn't ask 3 different objects, but it did it. So it's a red object as well, which is red material, and scene render, so it's did the objects and then save that as render, I hope. Save scene as output PNG as rendered, yep. But it's including the data and the camera and size of that image size as previous from part 1 and part 2 of this research out of 4. This is what I believe, but because we never set the camera, the resolution that is supposed to save that PNG. But as again, it's using from part 1 of 4, part 2 of 4 of this research with AI session series. Okay, those videos available on YouTube over the uhdking.com. So it did the load objects, data material, but I asked to apply the materials. So here's the new material. Red material will be Lampertian material. The glass material will be glass material. New metal material will be new metal material, and we have the material as classes available as again in part 1, part 2 of 4 of this video series of the researches with AI. So it's finished this. Okay, at least we got finished the code. In this example, and it's closed the quotes for us. This is unbelievable, guys. It's closed the quotes for us even. Check it out. In this example, the sim library is used to import an object file. The load object from object method takes in the file path of the object file and material object that will be applied to the mesh. Inside the method, the asim context class is used to import the file, and the post process steps triangulate and post process steps flip UVs options are passed in to ensure that mesh is properly triangulated and UVs are flipped. The method then iterates through each mesh in the imported scene, creating a new renderable object for each one and adding it to a scene object list. The material object passed in as an argument is used to assign the desired material to the object. In the main method an instance of metal material, glass material, and Lambertian material for red color are created and applied to different object files. Remember I asked the AI I should rephrase to load the different object files. I think it's listening to me, guys. Using the load object from OBJ, but I never asked. Method before rendering the scene and saving the output image file. Guys, it's already like 4 hours, I believe, this video. This is unbelievable. But this is the last part. Thanks God that we're not disconnected from the service. Okay, so we have this done. So this was that part of the code that it never finished the thought. Let me go ahead and finish the thought when it's integrated the open the different let me see. Wait a second. It was on top right here. We're gonna finish this thought, but when it's integrated the OpenTK. But I really like the first sample first to finish, and then the second one with the OpenTK. While it's using the, as well as it's using, as you can see, the integration of the SM with OpenTK together. It's nice to see the full examples of that as well. So I'm gonna say the same way that I stated before. First of all, I'm gonna place that in quotes, so it's gonna finish it. Okay, and I'm gonna ask the same way. So this is how you ask the question when AI is not finishing the thought. You're gonna ask, you didn't finish data data data. You didn't finish the code in C#, but could you please finish the code? I provide your code in quotes. Could you please finish it for me? I provide it, not provide, but provide it. I did a grammar mistake a little bit here in different times. Sorry guys. I'm really so hungry. Wanna drink. I'm finish my tea. I'm so thirsty as well. It's like 4 hours. So I provided your code in. Okay. So let's go ahead and have a look. It should do it for us. Yep. Here's the complete code. Now it's doing it. It's beautiful because now it's doing it in the code example and the code snippet in the black box. Here's the code. Here's the complete code for the glass material. No, this is not what I asked. Class, including the missing refract and schlick method. Wow, so the schlick method that AI was telling to us in the part 2 of 4 of the research under this series, it was telling us about the schlick method but never explained what it is. Look like it's used for the metal. Or for the glass material, but most likely maybe even for the metal. And missing refract method. But I didn't ask that. Why it's doing that? Glass material, hold on. Oh, okay, so it's finished the refract method. Okay, right here. Close it up. And now it's starting with the class material method. Creating the new class. Right? This is the glass material. Public glass material. But this is a method. This is not the class. Here's the class material. It's extending the material class. I don't know what's going on. Again, glass, material, extending material. Yeah, it's right here. It started from this point, guys. Public vector 3 albedo. And then it's going to go all the way to refract. Let's see. Scatter, all the way to refract. Right here, refract. Right here, refract. And now we stop like at schlick. Where did we stop? We did the refract in direction. Let's see. Refract in direction. We did the click and return true at the new ray. So return true at the new ray. right here, return true at the new ray. And we close it, and it didn't close it. It's stop here. So now it's continue. So this is the continue part of that. And then it created the schlick. Then it created the boolean refract when it's checking if we want to use it or not. And then the schlick. And then now it's closed that, and I believe it's closed the whole class of the material. Yep, that extended, which is the glass material. Okay, at least we got it going. Okay, so it was part of the glass material before the class metal material. I mean, after the class metal material. So now it's finished that. Okay, and it's using the OpenTK and SM. But now what I want to do, I want to finish the other one. I want to finish the other right here with the OpenTK as well. This one right here. The scene, my scene. I'm not sure what it was doing here, but maybe it's going to explain to us because after the code is explaining to us. So I'm going to go ahead and ask it to finish this one as well. Let's copy code. I forgot that I can copy code. Really neat that they did that code snippet option in the black box. Very great touch by the OpenAI developers in this ChatGPT. Such a unbelievable. So I'm gonna ask it again. I'm gonna put it in quotes, and I'm gonna say, hey, go ahead and do that for us, please. The same question. This is how you ask, guys, if AI didn't finish it for you. And if you still want to have it finished, this is how you ask. And you better get it finished because otherwise it's just waste. You don't want to waste it. You want to utilize it as much as you can for your researches. Even if it's free, but you know, they're utilizing their resources. Get that value. Okay, buddy, let's go ahead and create. Finish up. Okay, and it's finishing. Too bad not in the black box. Too bad, but object material, red material, it's in that if loop. So it's gonna close that if loop. They close that if loop. So I'm assuming that object material under that if loop. So object data 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 object material, then it's supposed to close this if loop. Nope. It didn't. If loop should be open with the bracket. So it's doing something else. Object material, let's see. Right now it's lost. So object vertices. Come on, it didn't finish that. So it's not part of the if loop. I don't think it's part of the if loop. Add object to this list. Okay, something is wrong here. The if mesh material cannot start without the open bracket and close bracket. So I'm assuming, okay, I'm assuming this is the if bracket, right? This is the if bracket closed. So it's part of the if bracket. So it just didn't open the if bracket. So you gotta, under the if mesh material index double equals 0, it should be if bracket open. And over here, I believe it's close the bracket. After I type a bunch of this one and close the if bracket, let's double check. And then it's going to be this for loop that should be closed. Right here, nope. But this is not the for loop closed, it's the whole method closed. public scene method. It's closed. So there is something going on here. Let me rephrase it. Regenerate the response. I did a mistake. It's doing the same thing. I don't think actually that this is a C# syntax. Did I ask in C#? I probably should ask provide the code in C#, because I don't think this is a C# right here, because it's not opening the bracket of if statement and not closing the if statement bracket. But it could be this if. Yeah, it is if, guys. As you can tell, this is this one right here, this one right here. So it should open the bracket, but right now it's typing not in C# syntax. So you should open the bracket and say object material, red material, data, 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 data. Then you should, and then you should say add object, and then you gotta close the bracket. This is under the if, okay? Because it's created some else if. But I'm not sure. And then you're gonna close that for loop bracket right here. The for loop is closed. This one right here, for loop closed. And then you're gonna close that method, which will be my scene method, okay? But let me actually ask it in a different way. I think it's going to retype it. It was confused. It typed in a different language. I'm gonna say, just in case we have this response, but just in case, I'm gonna say, could you please finish it for me? I provided your code in brackets. Could you please finish it for me in C#? In C#, because it's starting not in C#. Maybe this will be understandable. Nope, it doesn't do that, guys. It just not typing in C#. But we understand. I just confused that object add object. Is it under the else if, or I should close the else if and then it says should object add? I probably should close the if and set object add object and then close the loop and then close the method. So as you can see, sometimes it's typing like it's typing great, but sometimes it can type not like a C# language, and in combination with a C# language it can do that. But let's go ahead and have a look. Let's finish, and we're done with that. The next thing what I'm gonna ask how many cores supported by the Windows 10 and Windows 11 operating system and Windows 7. And I believe Windows 10 operating system professional version supporting all the way to 600 threads, logical threads. And if you want to go above that, you should use the Windows 11 operating system. But we're going to find out just in case, and as extra information provided to you. Anyways, guys, as you can see, it closed everything and then start even typing again. Oh, Jesus, bunch of mess. But at least it's typing now with the C# language. And it closed that, and it closed the bracket for us, so it's finished. And now, yeah, it's finished. I didn't explain what it did. Let me ask continue. Maybe it's going to explain what it did. But at least it finished the code because it did that double quotes. So at least it's neat when it's showing when it's finished the thought with the double quotes. Was a great touch by the OpenAI developers in this ChatGPT. Unbelievable. Even in this free public beta in January 9, 2023, it's beautiful. I don't think it's going to answer. It lost it. Like what I was typing there, I did an excuse there. No, look at this. No, it just doing it all over again, guys. It's already done that. Again, it's like create material as if it's still continue. Yeah, it's okay. But let's see. At least we can study this code in the future. At least I got the information and I can use this information as much information as I could. Wow, guys, I think this video is 5 hours already. But I'm pretty sure that I have enough of SSD storage space. I have like 200 gigabytes. After this video, I'm going to record a beautiful video for you of the Sniper Elite 5th Deluxe version on the Core i9-9900K overclock at 5.3 GHz with the Titan RTX video card in 4K video resolution. I'm gonna show you some DLC mission under that deluxe version that you don't want to miss, and the performance of the Titan RTX for those people that watching my videos on the Titan RTX video card, which is Turing GPU architecture by NVIDIA, TU102 GPU. And it's going to be a great video, guys. Sniper Elite, because I'm going to cover all the Sniper Elite series games on the Titan RTX video card in all kind of resolution. But Sniper Elite 5th PC game is pretty much look like it's going to be limited to 4K video resolution playable experience and benchable in 8K video resolution. But on the DLC mission, look like it's using the over 20 gigabyte of video RAM in 4K video resolution. So I believe it's going to overrun its video RAM. Maybe it's going to offload some data from a video RAM into the system RAM. Maybe it's going to crash under the 8K video resolution, but we are going to find out. But most likely it's not going to be benchable under the 16K video resolution. But if it will be benchable under 12K video resolution and 16K video resolution, which is 132.7 megapixels in real time per each frame, I'm going to go ahead and do it over the uhdking.com. You don't want to miss it. A lot of great videos in 8K video resolution gameplays, 12K video resolution gameplays, 16K video resolution gameplays that you don't want to miss will be available on the first video card, gamers video card, Titan RTX video card in all kind of different games that wasn't available before due that Titan RTX supporting 24 gigabyte of video RAM. I'm also going to use the Titan RTX in my AI adventures, guys, because it has a lot of neural cores such as tensor cores. As the first gamers video card with the neural cores or tensor cores by NVIDIA. So it's guys, you better subscribe for the uhdking.com YouTube channel no matter who you are. A lot of topics will be discussed no matter what industry you're looking to have the content. As again, unique content is going to be Gucci, guys. As again, don't forget to subscribe, share this video, and like this video, guys, so a lot of people can see it. Positive comments and watch my sponsors. A lot of time, money, energy, so I'm going to collect those pennies to compensate my time and invest towards you guys in the future projects and future content. All right, look like it finished because this quote means it's finished, which is nice. Neat touched, by the way, by the developers, as again by the OpenAI developers. ChatGPT tell us it's finished, but there is nothing else to say, nothing else to comment. We're fine. Let me ask, how many cores can be utilized under Windows 7? Actually, Windows XP. Let's go ahead and find out. This is for PC hardware enthusiasts that watching this video, PC gamers, PC overclockers, because you're watching it most likely because I'm going to release this app and you want to find out how I developed that. And this is information for you: Windows 8, Windows 10, Windows 11 operating systems. How many cores and logical threads? What is, not how many, what is the maximum? What is the maximum support of cores and logical threads per CPU that can be utilized? And guys, under the AIDA64 benchmark utility, it supported all the way to 2048 logical cores under the AIDA64 Business Edition. Under the AIDA64 Engineer Edition, I still also believe it's supporting 2048 logical cores, but under the AIDA64 Extreme Edition, which doesn't make no sense, only supported, I believe, all the way till 248 logical cores, I believe, which doesn't make no sense. AIDA64 Extreme Edition, which is benchable application, should support actually the maximum available logical threads and logical cores. I'm not sure why they did it like this, that business is top of the line in terms of the AIDA64 benchmark application. It should be AIDA64 Extreme should be the top of the top flagship, the top dog, but it's not. So I own them all, and I also gave away a lot of benchmark utility applications such as AIDA64 over the UHD King YouTube channel for you guys, over the UHDking.com. So hopefully some of you guys got it. Go ahead and let me know in the comments below if you were the lucky one, and hopefully guys you're using it, because the AIDA64 benchmark utility is one of the best out there. But I'm going to extend it, guys. I'm going to extend it, and I'm going to bring the new capabilities through my UHD King ray tracing CPU benchmark that you don't want to miss. Especially it's going to be a gift to the PC hardware enthusiasts, PC overclockers, PC gamers, while testing your CPUs and getting the results and compare the results and find out which CPU is the fastest on the planet Earth. It's going to be supporting all kind of different CPUs, as again, all kind of different devices. The maximum numbers of cores and logical threads that can be utilized on the different version of Windows operating system varies depending on the specific version and the hardware configuration of the hardware. Windows XP, the maximum number of cores and logical threads that can be utilized under Windows XP is limited by the specific version of the operating system and the specific hardware configuration of the computer. Windows XP Professional 64-bit edition can support up to 64 logical processors. Okay, this is a good information for you to know, guys. I did it on purpose to provide a multiple value, but other version of Windows XP is limited to 32 logical processors, and I believe such as Home Edition, such as like that. Windows 7 can support up to 256 logical processors. That's why I believe AIDA64 Extreme application is also supporting 256 logical processors, but as again, I'm not sure the naming of the AIDA64 application is incorrect from my point of view. Okay, as the software developer, as the user, as an entrepreneur, the marketing is wrong in terms of the titling of the EDA64 application, benchmark application. With a maximum of 64 cores, this is for Windows 7, and 256 logical threads. Most likely it's under Windows 7 Professional, 64-bit I believe, but could be under the old type of version, but I believe it's under Windows 7 Professional at least, not the Home Edition for sure. The Windows 8 can support up to 512 logical processors with a maximum of 64 cores and 512 logical threads. Okay, so as you can see, they look like Microsoft operating system is limited by the Microsoft corporation by artificially, and I hate when companies artificially limiting. But anyways, they trying to sell all kind of different edition from the marketing point of view. Windows 10 can support up to 512 logical processors, just the same as Windows 8, with a maximum of 64 cores and 512 logical threads. So this information is incorrect. Okay, I believe it's per node. It's support per node. Okay, because I had the my 72 core, which is 36 logical threads, which is the 18 physical cores CPU, which was 36 physical cores, but it was 72 logical cores, logical processors. Or maybe it's correct. Maybe actually it's correct. Yeah, so it was 72 logical cores with the hyper-threading technology, or 36 physical cores, and it had some problems to utilize after 64 logical threads and or logical cores, logical processors, because with the 72 logical threads or logical processors, it stopped at 64 logical processors or logical threads, and then it's like split it per node, and then you gotta utilize the secondary node. So it's like per each node it's 64 logical threads, keep that in mind, or logical processors. But we find out 512 logical threads probably makes sense, or 64 physical cores probably makes sense. Maybe it's per CPU or per ultimate support, we don't know. I'm going to ask the AI in a second. Windows 11 can support up to 512 logical processors, same as Windows 10, with a maximum of 64 cores and 512 logical threads. So same as Windows 10, same as Windows 8, and I believe this is per CPU, guys. It's not per the whole system, because as again, otherwise why EDA64 Business Edition or EDA64 Engineer Edition supporting above 512 logical threads or logical processors? And it's stated as supporting EDA64 Business Edition supporting 1024 physical cores. So I believe this is not per the system, this is per CPU, and EDA64 Business Edition supports per system. So I believe this is per CPU, but we're going to find out. It is important to note that the maximum number of cores and logical threads that can be utilized will also depend on the specific hardware configuration of the computer, such as number of CPU sockets. So as again, here we go. System, I mean more than one CPU socket, the type of CPU, and the amount of the RAM available. So additional, the specific version of Windows and the service pack level of the operating system can also affect the maximum number of cores and logical threads that can be utilized. So let's ask a question. Is Windows 11 operating system supports up to 512 logical processors per CPU socket, or per maximum CPU sockets. Windows 11 is the latest version of Windows. It supports up to 512 logical processor per system, so not per socket. Okay, so but this number can vary depending on specific hardware and configuration. The actual maximum number of logical processors that can be utilized on a specific system will depend on the capabilities of the CPU and motherboard, as well as the amount of RAM and other system resources available. It's important to know that Windows 11 has support for new technologies like ARM processors, which is nice, guys. In the future, I'm going to test my UHD King ray tracing CPU benchmark on ARM as well, which will be supporting the Apple devices and Android devices and the mobile devices, of course. And the number of logical processors supported by ARM processors is typically less than number of logical processors supported by x86 processors. Okay, let's ask, is this scenario apply to Windows 10, Windows 11 Pro? Yes, it applies to Windows 11 Pro. Let me ask Enterprise and Enterprise, so it's answer that. Okay, so it's a regular Windows 11, which probably home. I'm not sure if the home available, but under Pro it's home version, Pro and Enterprise. However, the actual number of logical processors that can be utilized in a specific system will depend on the hardware and system configuration. So it is what it is, guys. So I'm not sure. I think the Ada 64 business edition is lying in terms of the support of the logical processors or logical threads. Okay, I don't think it's supporting Ada 64 business or Ada 64 engineer version supporting 1024 physical cores. I don't think so. It doesn't make no sense. But maybe not on the Windows operating system. There is a possibility. Okay. Okay. So what else? What I want to learn? Let me ask it like this: can you output the all code examples that you provided throughout this chat in single chat, in a single text? I'm pretty sure it's not. Probably it's limited to the characters. Sure, here's the code I provided through this chat. Nope. Is it going to do the whole code? I need to have the whole code, not just the last example. Let's see. If it's going to provide the whole code, it's going to be amazing. So then I can copy and paste it. Hopefully this is not the last example. The tea is cold, guys. and I'm done with the tea. I'm hungry. I'm about to grab something to eat. Hopefully, guys, I provide so much value to you by watching this series. And for me, for myself, as experienced 3D artist, 3D animator, game, not experienced game developer, but have some experience with game development, programmer, which is software developer, but experienced software developer, PC hardware enthusiast, PC overclocker, system engineer. For me, for myself, I receive so much value throughout these 4 episodes of researching with the AI. It's just unbelievable, guys. So much information on all kind of different topics. Okay, so let me continue. Continue, please. No, it can't. No, you can't. Why you stated that you can when you can't? As they were provided in response to specific questions and might be able to, in the same project, which is additionally, can you summarize? Additionally, some of the code examples were incomplete and were intended to be used as a starting point for your own implementation. It's best to review each code example and understand how it can be used in your specific project. If you have any specific question or issue with any of code examples provided, I would be happy to help you further. Okay, let me ask another question. How can I save this whole chat as PDF for my offline researches? That includes all the answers and questions through this specific chat. I don't think there is an option, but let's go ahead and ask the AI. There's a few ways to save this chat as PDF for offline research. Here's a few options. Take screenshots. No, this is not good approach of the chat and then combine them in a single PDF using a PDF editing tool such as Adobe Acrobat or free of online service like Small PDF, but then you cannot use the code snippets. Second, if you're using a browser, you can use a browser extension such as Print Friendly and PDF or Save as PDF, but it's not saving as Save as PDF. This is the deal. To convert the chat into PDF. If you are using a mobile device, you can screenshot of the chat and then use the mobile app such as Adobe Scan or Genius Scan to convert the screenshot into PDF. If you are using a desktop chat application, this is what it is. You can copy and paste the chat into a word processing software such as Microsoft Word or Google Docs, and then save this as PDF function to convert it into PDF. But I don't believe that copy and snippet will go well with the old text. Alternatively, you can use the chat conversation backup tool available for your chat medium to back up this conversation and then convert the file to PDF. How to do that? Let me ask that. How to use chat conversion backup tool available for your chat medium to back up the conversation. This is the best way probably, but how to do that? This is, guys, a value for you because I found out there is no way to save it as PDF without spending like hours, or it's like big pain in the ass. How how to chat conversation backup tool, how to use or access chat conversation. Oh my god, can you believe this? It's like us, guys, but look like we are done everything. Everything what we can do, we did it. Okay. Yeah, but look at this, this is so not cool. It's like us, but what about if I'm gonna reload? Reload, not reloading, not, here we go. Reload and let's see guys. So Control A is selecting everything, so it's not useful as you can see because it's not a frame. But if I'm going to go ahead and select like that, and then I'm going to page down. So select everything and page down. This is probably the best way to do it, guys. But there is no way to save it as PDF, believe me, guys. Like that, page down, and now we select everything. Everything. Okay? Now you can go ahead and right button and print, save as PDF. And look how ugly it is. It just, and this is the way, guys, but as again, it's not formatted correctly. Landscape, pages all, more settings, letter. Let's go ahead and do the tabloid. Let's see the tabloid. So this is the way, guys. This is the only way. Maybe legal. No, it just doesn't wanna. What if I'm gonna do this selection only without background graphics? But then you don't know where is the code. But code can be displayed like this. Yeah, it doesn't help. What about the headers and footers? Disabled. Nope. Not gonna give us anything. It's not formatted, guys, correctly. And scale. Let's use scale. Okay, no. Default scale 100%. None. Merging. None. Minimum. Custom. Minimum margins. Nope. Default. 127 pages, guys. This is going to be our research. Tabloid. Yeah. I don't know, guys. So this is how we're gonna do it. So at least we can watch it. And so just in case, so you can print it out, I better save it as legal. This like 16 divided by 9 aspect ratio almost. So you can print it on legal. What about the letter? Legal is kind of not popular format. What about letter? So you can print it out if you need it. Yeah, let's use that. This is unbelievable, guys. And now you can save it. Okay, you can click save as PDF, as you can see. Microsoft Print to PDF. If you don't have save as PDF, you can use the Microsoft Print to PDF, and it will give you the ability to let me show it to you. Pretty much the same options how you can do it. Okay, like that. Is it? But it didn't format it, so you gotta reformat the whole deal in your Visual Studio IDE, C Sharp IDE. It's going to be a little bit of pain, but at least you can save it. This is the only way how you can do it, guys, because if you're gonna save without selecting everything and page down from the top all the way to bottom, then it's just going to save as PDF just that page, just this little right here, just like this page. It's gonna just save that amount to PDF. You can do it as a screenshot, but you're gonna do it like this as well, and it's not good. The approach is horrible, terrible, and if you're gonna save it as screenshots, then you're not going to be able to copy the text. So you can do the research, but you gotta retype everything. And over here, you can copy and paste this, okay, in your Microsoft Visual Studio IDE. While using the C Sharp or wherever you're using. Anyways, guys, all right. So pretty much that's it. This is we're gonna end up with this part of the research. As again, on the background, the audio track is outright reserved. There is no royalties can be claimed. Was provided by the YouTube, and thank you so much to the YouTube for that. The name will be Yoga Style by Chris Hogan, and as again, my name is UHD King, or I play 4K, aka I play 8K, aka I play 16K. We're gonna wrap up with the researching with AI while creating the application in C Sharp. In our case, UHD King, retracing CPU benchmark application, and we're going to keep moving. We're going to start. This was the part 4 of 4, which is 4 parts. Now we're gonna keep moving. We're gonna go to step 2, stage 2, because this was stage 1, and stage 2 will be also multiple parts where we're going to integrate these researches into the Visual Studio while using the C Sharp language and in the IDE of the C Sharp Visual Studio. And we're going to go ahead and pretty much try to compile the application. We're gonna debug and test in real time. We're gonna find out if we need to add additional information, and if so, we're going to also research this through the ChatGPT. Okay, and it's going to be stage 3. So stage 2, we're going to wrap up the final beta application, which we can test, and most likely I'm going to share with you. And part 3 will be the optimization. Okay, and not the part 3, sorry, stage 3 will be optimization, and stage 4 will be advancing the application to another level. Okay, I'm not sure if I'm going to share with you the stage 4, but stage 2 will be shared with you for sure. Probably I'm going to share with you stage 3, which will be optimization. We're going to use again AI while we're going to optimize the application already ready code. And yeah, that's pretty much it. Have a good day, good morning, good evening, good night, and I will see you guys in the next videos. Go ahead and check out uhdking.com. It was provided to you by the Artistic Bytes, and yeah, this is going to be a great video for you to watch from start to finish. I will see you guys till the next time.